Oh,
Yep,
well,
now it's recording.
Yeah, now it's recording.
So Maddie, did you get into any of the smart contract code stuff at all? Like how they like, from my understanding, smart contracts are actually like little triggers of code inside of the block.
I didn't get into that very much, but I did read a little bit about smart contracts. There's a lot there.
Yeah, for sure. For sure. I read something about like this company, I think it was like DOA or DAO. They were like, hey, we're going to innovate with smart contracts. And what they ended up doing was coding a bunch of.
Don't steal my thunder.
All right. Sorry.
Smart contracts is like my whole presentation.
Eric should go next.
Oh, but I go last.
Come on, mix it up. I'm done.
all right. Who wants to go next?
I think Eric volunteered.
I just simply didn't want everybody to steal my thunder, but I have no problem going next too.
Okay, I will go.
I think Camilla was about to volunteer, so sorry, Camilla.
No, I volunteered Eric to go.
All right, that's good. Me too.
All right, so Eric's going?
All right, sure, give me a second here. There's that. So, yep. Let's try that too, and you guys will need screen too. All right. Sweet. So, do you guys got me?
Yep.
All right. Okay, here we go. So we're going to be taking a look at smart contracts on the blockchain. It's a new innovation that's becoming quickly popular, as was kind of hinted to a little bit by Maddie. And it looks like it could potentially make traditional contracts obsolete. But to give you an idea of what they do and how they work, let's dive into them a little bit here.
What if there's a technological advancement so powerful that it transforms the very basic pillars of our society? A technology which fundamentally influences the way that our economy, governance systems, and businesses function, and could change our conceptual understanding of trade, ownership, and trust. This technology already exists, and it's called cryptocurrency. People often think of Bitcoin as only virtual money or a transaction system. But if you look closer, you'll see that the monetary aspect is just the tip of the iceberg. That's because Bitcoin is a groundbreaking internet technology for which money is merely one of the possible applications. Money exists to facilitate trade. Through the centuries, trade has become incredibly complex. Everyone trades with everyone worldwide. Trade is recorded in bookkeeping, and this information is often isolated and closed to the public. For this reason, we use third parties and middlemen we trust to facilitate and approve our transactions. Think of governments, banks, accountants, notaries, and the paper money in your wallet. We call these trusted third parties. This brings us to the essence of Bitcoin. Bitcoin software enables a network of computers to maintain a collective bookkeeping via the internet. This bookkeeping is neither closed nor in control of one party. Rather, it is public and available in one digital ledger which is fully distributed across the network. We call this the blockchain. In the blockchain, all transactions are logged, including information on the time, date, participants, and amount of every single transaction. Each node in the network owns a full copy of the blockchain. On the basis of complicated, state-of-the-art mathematical principles, the transactions are verified by the so-called Bitcoin miners, who maintain the ledger. The mathematical principles also ensure that these nodes automatically and continuously agree about the current state of the ledger and every transaction in it. If anyone attempts to corrupt a transaction, the nodes will not arrive at a consensus, and hence will refuse to incorporate the transaction in the blockchain. So every transaction is public, and thousands of nodes unanimously agree that a transaction has occurred on date X at time Y. It's almost like there's a notary present at every transaction. This way, everyone has access to a shared single source of truth. This is why we can always trust the blockchain. The ledger doesn't care whether a Bitcoin represents a certain amount of euros or dollars, or anything else of value, or property for that matter. Users can decide for themselves what a unit of Bitcoin represents. A Bitcoin is divisible in 100 million units, and each unit is both individually identifiable and programmable. This means that users can assign properties to each unit. Users can program a unit to represent a eurocent, or a share in a company, a kilowatt hour of energy, or a digital certificate of ownership. Because of this, Bitcoin is much more than simply money and payments. A Bitcoin can represent many kinds of property, 1,000 barrels of oil, award credits, or a vote during elections, for example. Moreover, Bitcoin allows us to make our currency smarter and to automize our cash and money flows. Imagine a healthcare allowance in dollars or euros that can only be used to pay for healthcare at certified parties. In this case, whether someone actually follows the rules is no longer verified in the bureaucratic process afterwards. You simply program these rules into the money. Ergo, compliancy up front. The unit can even be programmed in such a way that it will automatically return to the provider if the receiver doesn't use it after a certain amount of time. This way, the provider can ensure that allowances are not hoarded. A company can control its spending in the same way, by programming budgets for salaries, machinery, materials, and maintenance, so that the respective money is specified and cannot be spent on other things. Automizing such matters leads to a considerable decrease in bureaucracy, which saves accountants, controllers, and the organization in general an incredible amount of time. The programmable open character of Bitcoin allows us to completely rebuild and innovate our financial sector and our administrative processes, make them more efficient and transparent, and significantly decrease bureaucracy. But there's more. In an Internet of Things, our economy will be dealing with machines that actively participate in the economic traffic. In fact, they're already here. Think of a vending machine, or drones delivering packages. These machines are unfamiliar with the concept of trust, but Bitcoin is not. Because of Bitcoin, the drone can be 100% certain that it will deliver the package to the right recipient and know for sure that it's been paid for. And we can program the vending machine in such a way that it will automatically keep track of its supplies, order new supplies from the supplier, and pay for them automatically. Of course, you'll understand that this is only the beginning. Internet technology is disruptive and breaks the status quo. It opens markets and breaks the positions of middlemen all the time. Bitcoin and cryptocurrencies have caused a paradigm shift. It's time to explore this new technology constructively and critically, and openly discuss potential applications.
So, as you can see, there's a lot of good things that come along with blockchains and smart contracts. You know, first off, you have autonomy, because now you're not working with intermediaries like an insurance company or a notary. You're just two parties who create a contract with each other. You don't have to worry about third parties who can have biases or interject issues into it. Secondly, you have backups. I mean, imagine for a second if a bank lost your savings account. What are you going to do now? There's no record of it. But with the blockchain, each and every one of your friends, neighbors, relatives, people you don't know has your back, because your documents are duplicated across the entire network. You have the safety of cryptography, because all of your documents are encoded. It would take an extremely abnormal hacker to be able to crack those codes in a reasonable amount of time. Like Maddie mentioned, you have a lot of speed that's generated into this, because you're not having to go through and look at each piece of paper, each form. It's all done in computer code. It just automates the entire task, shaving what could be literally hours off of a transaction. Again, you have the savings that go along with this smart contract because now you don't have to worry about paying for other people and other goods and other services in order to initiate this contract. No offense, in some ways, Maddie, you'd almost be out of a job if smart contracts take off. Becomes kind of the issue with as we see it. On the flip side of this, there's the bad, right? Because smart contracts are so new, we have questions of their legality. Our laws that look at contracts are not built for smart contracts, and that becomes an issue. For example, one of the big things that came up in the research I was doing is smart contracts don't understand what it means to be in breach of contract, because it's just a if-then statement. If certain conditions are met, then this task happens. And smart contracts don't understand what happens if somebody breaches that. It's also written in a programming language, and as we're all well aware, we're part of a small group of people in the world who understand what it means to program and how programming languages work. Smart contracts are traditionally written in a language that looks similar to JavaScript, which means that they're in an even smaller pool of people who actually understand what computer code is being written. Smart contracts don't understand when a contract is finished. Unless it has input from both parties that says, yeah, go ahead and release the then portion of our contract, it has no idea, which means that if you want to take advantage of somebody, you can just simply not release the funds. Smart contracts also are prone to, well, as we all know, even the best of us programmers writes bugs every now and again. Smart contracts are, by definition, immutable. That means they can't change. Once they're in the blockchain, they cannot be modified, which means if you program a bug into your contract, that could have disastrous consequences. Finally, as some of us were starting to allude to, there are some vulnerabilities in the blockchain. One of the things that gives a blockchain its good name is that it's controlled by the public and not by companies, but there is, as it were, the ugly part of the blockchain. In 2016, there was a company called Ethereum, which has built their name on building smart contracts, and their company was holding in its network a $50 million contract of its what they call Ether credits, which is similar to the Bitcoin idea. They were holding them for this project called the DAO, and 50 million was stolen from them. Now, this might seem like a lot, but their chief operating officer wasn't really worried about it because all the cryptocurrency that's being stolen was all traceable, right? Everything had a tracking number associated with it. I love the quote that he says when he was interviewed. He said, it's like stealing the Mona Lisa. You know, he says, great, congratulations, but what are you going to do with it? You can't sell it because it's too big to be sold. And that really is the same thing that goes along with this blockchain. The issue came up with how they tried to fix the hack. Ethereum forced its users to do what the blockchain calls a hard fork, which means that everyone had to update their software, and in the process of updating, they got a new ledger, and the processes were invalidated. It restored the funds to the DAO, which one could consider nice on the one hand, but it violated the core belief and the benefit of smart contracts, which means they're protected by the public and not a private company. So smart contracts, they're a new and innovative idea that could revolutionize the future, but there's still a lot of issues that need to be worked out before we fully get there. And that's what I got. Questions, comments?
Any questions?
Yeah, so do you think that, I read the same concerns, like, you know, I read a programmer who I think helped like make traditional databases, but now he's like a venture capitalist, and his big thing was that he's like, it just will never get there. It's promising too much. like it's a great idea, but because smart contracts are inherently buggy, like if someone knows what they're doing, like they did with that Ethereum blockchain in that company, like if someone codes a bug in it, it's propagated all over the place. And I guess one of the things that they struggled with was like reaching a consensus via the blockchain consensus mechanism on how to patch it. They were trying to figure out how to get consensus to patch, and then the guy laid off with it.
Yeah, that was the bulk of an article that I read as well, because some people, Ethereum threw out quickly, hey, we could just hard fork this, and everybody's like, why would you do that? That defeats the purpose of why we're doing this in the first place. But yeah, that really does become the thing. There's a lot of really cool things that the blockchain promises to do, but I mean, here becomes the other thing that I was thinking about as all of this is going on. There's no, at least in the research I was doing, there's no termination of the blockchain. It just keeps getting bigger and bigger. So then the question becomes, at what point do we run out of space to keep track of all the transactions that happen? I mean, granted, your transactions are taking up small bits of space, but space isn't free and it's not unlimited, even though, Amazon and Google would like us to think so.
I saw a graphic from the Department of Homeland Security that actually came up with a flow chart of like, is this a good blockchain app or is it not? And they actually, did you see that, where they kind of like walk you through like, should you solve this with blockchain? And they had a bunch of kind of logic statements to guide you through it.
I did think it was kind of interesting. In the video, they bring up the whole vending machine drone delivery thing. And I do think that would be a really interesting blockchain usage. If the vending machine is just like, oh yeah, I'm out of, I don't know, Coke or Pepsi or whatever. And
yeah, that was actually my question. Like in your studying, I'm still trying to wrap my head around proof of work or proof of stake and all the different consensus mechanisms that you use to validate transactions in the blockchain.
Yep.
And they make sense in like a Bitcoin world, even though they're getting progressively harder. And so therefore we're kind of wondering like, well, is Bitcoin sustainable? Because we're going to end up, a lot of people are worried about environmentally nuking things with like the power that we're going to consume for Bitcoin. For like a vending machine and things that need to like transact quickly, do you know, like, does a smart contract not use a proof of work mechanism? I was trying to figure that out. I didn't find it in my studying.
Well, I think the proof of work would just be you could argue, right, the change of weight from, if, for example, in the drone scenario, the drone's going to load up, I don't know, to use my analogy, 50 bottles of Coke, and drops it off at the vending machine. Now that weight is out of that drone.
Okay.
But yeah, I mean, it becomes one of the question marks that come about with the blockchain is, how do you know when that work is done?
Yeah, so different. So Seth, to answer your question, it's not connected to. So smart contracts is a feature of some blockchain algorithms. Another feature of some algorithms is how tokens are distributed based on proof of stake versus proof of work. And this is for the validation process of how transactions are validated on a particular blockchain. So it's not necessarily connected to whether or not a blockchain is compatible with smart contracts or not. It's whether or not validating a transaction, whether you're paid for validating a transaction, if you're helping with the execution of the blockchain, is done based on the amount of work you do, the amount of numbers you crunch. So this would be like Bitcoin mining, for example, is a proof of work based approach. Whereas proof of stake would be, they encourage people who are mining, quote, mining, to be part of also the holders of tokens. So the more, if you want to think about it like US dollars, the more US dollars you have, the bigger role you're playing. That's your proof of stake. The bigger role you're playing in the validation of other transactions, because it's in your best interest that transactions are secure because you have lots of these coins, something like that. So you could have something that is an algorithm that does not support smart contracts. For instance, Bitcoin, which is kind of interesting based on Maddie's video, Bitcoin inherently does not support smart contracts. Yet the guy was using Bitcoin as the example for the smart contract based insurance example. That doesn't mean you couldn't build that on top of the Bitcoin blockchain, but as Eric pointed out, Ethereum was built around the idea of smart contracts. That's kind of was like its bread and butter, if that was the what was its selling point, if you will.
Yeah, no, I was trying to figure out, like, it makes sense in crypto markets. Like, okay, we're going to incentivize you by rewarding you for validation. Here's, a transaction fee. Here's your currency. But like, say, like I was reading about smart grids, and they need fast transactions because we're generating electricity and it kind of moves really fast. So if we're going to meter this out, our blockchain needs to be really quick, transactionally quick to in order to assess, like, how much electricity you threw into the grid. So we're keeping an accurate ledger of it. So how do you incentivize people to validate in that market? You know what I mean? Like, I get that there's different mechanisms, some of which, like the proof of work versus proof of stake, is kind of like, if you're a large stakeholder, it's actually in your interest to do the validating. They make it worth your while to do it.
Sure.
And they don't need the big cryptographic puzzles for you to solve. But I was trying to figure out.
And what you're actually bringing up, I think, is one of, and I don't want to, if somebody else's talk really gets into this, I don't want to necessarily, does anybody else get into this this concept before I answer the question?
We can leave it be. We're going on someone else's time, and we'll see if it comes up.
Okay, but yeah, I have a fairly strong background in blockchain stuff, so kind of store your call them fancy questions for the end, and if they don't pop up during the one of the talks, we could have a little powwow at the end to kind of talk through it. But I mean, it's an interesting thing, and just to kind of if we're going to pause the question, that's fine. But just to Eric's point, it's kind of the inherent problem with blockchain technology that some of the very things that are the rules for the technology are often broken to maintain the technology. So now you're right back to having to trust the man. Where there isn't
there's that centralized authority's got to give a guarantee of some kind.
Right. Because it is kind of interesting that our whole society is built on top of trust. And I wonder if we can ever get away from that. And that kind of plays towards, Maddie's approach for, actually two comments. So Maddie's whole thing on, it kind of revolutionizing the insurance business, but also Eric's comment that, if we perfect this blockchain stuff and it's widely adopted, we're going to see a lot of industries disappear. I think it might be tough for that to happen because human beings are involved in it, and we rely on trust, even though we say we don't want to trust any individual. So it'll be an interesting thing. But
last philosophical point, my dad would often tell me, you trust that your car seat won't fall through the bottom of your car when you get into it. So, I mean, trust is kind of at the rock bottom of everything we do.
Yeah, no, and I get it. It is, a very interesting thing, but I think with a lot of, and I think that's one of the interesting things with blockchain is it's mathematically complex enough, and hopefully most of you kind of ran into this as you were looking at the stuff, where it's kind of like you basically understand it, but it almost feels like it's a little bit out of reach. Some of the details of it, like because it's very mathy under the hood, whatever is happening, and that goes to the complexity of it. Which then goes back to some of the other things that you were asking about that we could talk about at the end. But how user-friendly is it? Do we imagine that grandma is going to be using Bitcoin to buy milk? I don't know if that's going to happen anytime soon. But yeah, I think inherently people like trusting other people. We just are very particular about who we trust.
Well, in the curiosity that I had is, at what point does do we put a user interface in front of the blockchain, and then does that become the exact same thing that we're doing? We're just using a different technology on the back end to execute it, right? I mean, for grandma buying milk as the example, well, grandma could probably buy the milk if she had, an easy app where she, opened it up and pressed, buy milk, where all of the blockchain stuff happened automatically behind the scenes. But does that then completely invalidate the whole point of the blockchain? Because now you've got another trusted third party in the middle.
Yep, you gotta trust somebody.
Yeah, right.
All right, who wants to go next?
I will go.
All right. That was Josh, right?
Yes.
All right, you're up.
Okay. Good evening to everyone. Today I will be presenting on my topic on blockchain. Without wasting my time, I would like to go through one by one what I have. So first is what is a blockchain? Blockchain is an undeniable genius invention, and also it is also considered one of the emerging technology in this world. A technology that has potentiality to transfer the business sector. And also actually this blockchain was invented in 2008 by a person or a group of people using, his name is Satoshi Nakamoto. Blockchain is a database or digital ledger of transaction. In another way, I would like to explain the blockchain is actual information while chain is a public database where the block is stored. Blockchain database is different than a traditional database. In traditional database, the data is stored in the centralized server where the single authority can manipulate the data, change or do the manipulation of the data. But in the blockchain, data is shared in the network, which is run by special software. Types of blockchain. There are 4 types of blockchain. I will be going quickly one by one because I have a less time. In public blockchain, everyone can access who has internet facility and become a authorized person. But in the private blockchain is only single person can be authorized. Third is consortium. It is a kind of a semi-centralized blockchain where the network is managed by more than one person. Hybrid blockchain is especially good for generating the hash or code. The blockchain contains 3 parts. Number 1 is a block store information about transaction. Blockchain is really new method of record keeping its ledger. Blockchain keep records such as a date, time, amount of purchase. It is not a centralized mechanism where else have one entity, but is decentralized system where the network of computer get together and work together with the agreement of algorithm to distribute large record. All the computers which are in network, they think that transaction must happen, should keep the transaction and it get into process. Whereas if they do that, that will produce the trust among the people and mediator will be no longer valid in that. Second, blockchain store information about who is participating in transaction. In this second point, I would like to explain blockchain stores information who is actively participating in the transaction. Let us see, as per the picture I have given example as a Alice is a buyer and Bob is a seller. Let us say Alice wanted to buy a house and she find the house which she like and decided to buy. When she buy the house, owner Bob has to sign the document which says that now Alice is on the house. At the same time, Bob also has to provide the proof when he has bought the house from the previous owner. Previous owner also has to sign the similar type of documents that which says that Bob is the owner of the house. Same in another way, I would like to explain that the word has been proved that means it is chain of ownership of the house. So blockchain is like that. For the each unit of the chain, it has been cryptographically verified chain of the history. Anyone can see in the chain of the history who has bought the house, who was the previous owner, how much it cost the house, and what is everything they can find out. Third thing, block store information that differs from other block. In this third point, each block stores the unique code called the hash, and the hash tells us it is different from other block. Hashes are also cryptographically coded by the special algorithm. Let us say you made a purchase in any online shopping. When you purchase, then transaction will be proceed. At the same time, if you want to buy another purchase, so when you buy this other purchase, so the transaction receipt will be almost same. It is identically, but we can still find there is a block, a part of the Unicode has, different transaction it will show. As we had pointed 3 points, what is the blockchain? Now we are going to see how the blockchain works. In this 4 points, the blockchains are in the blockchain. In this 4th point, blockchain must 4 things must happen. Without 4 things happening, we cannot call that this is a blockchain. Number 1 is transaction must occur. Let us say you make a purchase online shopping in Amazon or any other online shopping. You make a purchase, the block will group together potential thousands transactions together. And the purchase you just made will be packed in the block along with other buyer or users. That is going to happen. Second is the transaction must be verified. After you made a purchase, your transaction must be verified with other public record which will give a security. However, this job is left up to the network of computer. When you make a purchase from Amazon or any other online shopping, the computer immediately will rush and find out, and they check it if this transaction has happened correctly in the way you wanted, and they will come back to you with the confirmation details of purchase, such as like date, time, amount of money. Another, the transaction must be stored in the block. After the accurate verification of a transaction, you will get a green light kind of the amount of transaction and the signature of the buyer purchaser will be there and is stored in the block. Another, block must be given a hash. Without hash, as I showed, without hash, we cannot call this blockchain. Because each block has unique identification code called a hash. Let us see how the hash work in practical ways. So I have found some picture. I would like to explain each by one. In the first picture, we see that here we have a block, 3 blocks. Each block contains data, hash, and hash of the block. And the data that are stored in the block, each block has different type of data. For example, Bitcoin store the data that has sender, receiver, and amount of money. Then another second block is called a hash. In the block also has a hash. And hash, when you make a change in something inside of the block in the hash, automatically what will happen, hash will be changed. So in this picture, when we see that there are 3 blocks are there, 1, 2, 3, which is third is pointing to 2, and second is pointing to first block, and first block has this uniqueness, they don't have a previous hash. When in this second block, when you change something, when you do something in the block, second block, then hash will be changed. And when the hash will change, automatically in a third block will be invalid. It will show is invalid. So what I want to say, in changing a single block will make following block invalid. So one of the reason this blockchain is very good. Future of blockchain technology. Future of blockchain technology will move to the distributed property and trust. Anyone who has internet can be involved in the blockchain technology, and third party will be no longer important. Some of the people, researchers, they says that after 10 years or after few years, this blockchain technology will be used to collecting the taxes, and as well as it will be very helpful for the business people to send money overseas, which will be good for the business people to not happen a financial fraud. It will reduce the financial fraud, but blockchain technology will build the trust in transaction. So that's a very important thing. Thank you. If anyone have question.
All right, any questions? We got nothing? All right. Coming up next is Ani.
Awesome. All right, let me share my screen. Can everybody see it okay?
Yes.
Yeah.
Sweet. All right. So kind of going along Similar to what Maddie did, where she picked a topic that was in her industry that she works in, I'm going to talk about blockchain in the mortgage industry because I work in the mortgage industry. So what a block? Terms and definitions. So hashing is a method of applying a cryptographic hash function to data which calculates a relatively unique output for an input of nearly any size. So it could be like a file or text or an image, anything like that. It allows individuals to independently take input data, hash the data, and then derive the same result, proving that there is no change in the data. So even the smallest change to the input, even changing just a tiny, tiny bit, will result in a completely different output. So cryptographic functions are used for any tasks such as like address derivation, creating unique identifiers, securing block data, and securing block header. And then for a transaction, for business-to-business scenarios, a transaction could be a way of recording activities occurring on digital or physical assets. The data which comprises a transaction can be different for every blockchain implementation. However, the mechanism is for transacting is largely the same. A blockchain network user sends information to the blockchain network, and the information sent may include the sender's address or another relevant identifier, and they send the sender's public key, a digital signature, and transaction inputs and outputs. So inputs are usually a list of digital assets to be transferred. A transaction will reference the source of the digital asset, either the previous transaction where it was given to the sender, or for the case of new digital assets, the original event, the origin event. And then outputs are usually the accounts that will be the recipients of the digital assets, along with how much digital asset they will receive. So each output specifies the number of digital assets to be transferred to the new owners, and the identifier of the new owners, and a set of conditions the new owners must meet to spread that value. And then there's also the ledger that is basically a collection of those transactions. So the main components of the blocks, there's the block header and the block data. So transactions are added to the blockchain when a publishing node publishes a block. So a block contains a block header and block data. The block header contains metadata for this block. The block data contains a list of validated and authentic transactions which have been submitted to the blockchain network. Validity and authenticity is ensured by checking the transaction is correctly formatted and that the providers of digital assets in each transaction have each cryptographically signed the transaction. So this verifies that the providers of the digital assets for a transaction had access to the private key, which could sign over the available digital assets. The other full nodes will check the validity and authenticity of all transactions in a published block and will not accept the block if it contains invalid transactions. So here's kind of a picture of how the blocks kind of look. So you got the block header and the block data, and then with the hash you have usually contain, see how it says like block 1 header and then block 2 header, and then you got like the hash block data. You're also, what kind of connects the two is that the next block will contain information about the block following. So it's kind of, that's how it's like connecting each other. There's usually like a root, and then this block will contain information about this one, and then this one about this one, and so on and so forth. So kind of a better explanation of that, blocks are changed together through each block containing the hash digest of the previous block's header, thus forming the blockchain. So if a previously published block were changed, it would have a different hash. This in turn would cause all subsequent blocks to also have different hashes since they include the hash of the previous block. This makes it possible to easily detect and reject altered blocks. So traditional mortgage application process problems. So kind of what are the problems in the mortgage industry right now? So the traditional mortgage application process leads to three main problems: increased costs, extended processing times, and lack of transparency. So these first two kind of relate to how it works in the insurance industry. So you'll see a little bit of overlap there. So the current transaction flow requires third-party input from credit agencies to help access loans, loan eligibility, underwriters to calculate and ensure the accuracy of mortgage drawdowns, surveyors to provide up-to-date property valuations, lawyers to draw up legal documentation, and title offices to confirm and update the ownership. So each of these functions is likely to have a large team of administration staff to deal with the physical paperwork. I got this quote from PwC. The average mortgage application includes about 500 pages, a number that has trended up rather than down in recent years. This was back in 2015. Although other reports suggest that it may be as much as 2,000 pages. So, and lastly, the lack of transparency over the required application documentation is a big problem. So bank accounts, title deeds, and government records are held by separate institutions. So when a person applies for a mortgage, brokers, credit agencies, bank personnel, and other third-party agents will need to access this information in order to determine if a loan should be approved. So access is usually provided through manual processes like sending an email request and then receiving the information a few days later. Once a mortgage is approved, the same information needs to be updated with every agency. The title deeds need to show that the property has changed hands. The bank will now need to keep record of the mortgage against your name so that credit agencies can access this in the future for other loan applications. This is again done manually, and every time information is passed along, it moves from one lender to another. This not only requires additional third-party agencies to confirm these transactions, but it means this paper-based, mostly manual process is prone to human error, kind of what Maddie was going and also talking about, which kind of leads to further delays and cost accumulation. So how can blockchain help? So the elimination of documents. To prove a line of credit, banks rely on accurate information from surveyors, law firms, credit agencies, etc. If all of the required information is securely stored on a distributed network with each agent updating their part of the information, banks can easily retrieve the various pieces of information they need from this network without having to rely on an individual. Paper-based communications to each of the third-party providers. So this includes digitized copies of legal documents, property valuations, and title deeds. So quicker verifications of changes will ultimately mitigate the accumulation of documentation, not only limiting the opportunity for errors to creep into the paper trail, but also curtailing the need for long-term storage of documents, both physical and digital. Because all the parties use the same document, each step in the process can happen more quickly and openly with a verified moment in time when changes are carried out. So again, the idea of like the smart contracts, which are coded sets of rules that trigger when a specific event occurs, which you've already heard. For example, if a buyer purchases a homeowner's insurance, the mortgage can move to the next step in the process automatically. So transparency, DLT is secure and creates by its very nature a transparent audit trail. So each block is added to the chain is an open snapshot of a data point, which restricts the opportunity for fraud and manipulation of information. mistakes can be corrected with subsequent blocks. Even though access to sections of the chain can be limited, which satisfies privacy concerns, the block itself is permanent and can always be read at a future date. And then lastly, lower cost. The result is that certain roles of costly lawyers in the mortgage application chain can be made redundant. Information in the blockchain won't be proprietary to any single service provider, such as a lawyer or credit agency, and therefore fees for accessing information won't be added costs to the process. If entities go out of business, documentation could still be retrieved quickly and easily. And since this is my last slide, you guys know what this is. It took me a very long time to find this picture, and I hope you guys enjoy. Any questions?
A croc eating a croc. Ha, 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 ha.
I have one.
I
Thank
have
you.
one question, Ani. Do you think
Yeah.
that, they will need some sort of versioning, like a document version as a part of the payload of the block? Because I imagine that at some point they're gonna like want to tweak that thing and say, oh, we didn't account for this, so now like, you know, instead of like the single document won't last forever. So, you know, I agree with what you're saying. It's like, yeah, there's gonna be a lot less paperwork. And I wish that this existed, because when I bought my house, it took forever because it was a short sale and I didn't know it was a short sale. And when you go into short sales, like the banks just like throw it into a drawer and burn it in there. And it's just like, yeah, we'll get back to you sometime in the next year. So I think this is pretty cool. But
Cool.
yeah,
Yeah.
in your research, did you ever come across that? Like, we'll need like a mechanism to figure out, like, say, what mortgage protocol we're using?
That's a good question. What I really wanted to go into was the mortgage, like which companies are currently utilizing blockchain that are in the mortgage industry, and kind of dive deeper into how they're implementing it. But I didn't get a chance to do that. It just, the presentation just would have been a little bit too long. So no, I don't have a good answer for that.
That's fine. I was just curious.
My question was, do you think that paper will ever go away in the mortgage industry?
I think that, I mean, from what I know and the people that I've talked to within our company, we've gone a really, really long way from starting off solely on paper. And Optimal Blue, the company that I work for, is really making it what used to be very, very paper, very digital. So I feel like, yeah, we are moving in the direction of going completely digital. But do I think that we'll go at some point completely off of paper? I don't think so. But that's just my opinion.
Yeah.
Littman, what do you think? Just out of curiosity.
Well, I think we'll probably go completely off the paper at some point.
Really? Okay.
Yeah, I mean, the question is when.
Oh, when?
Yeah.
Was that your question, Maddie? When do you think?
No, I just asked, do you think that we will?
Yeah. I personally don't think that we would or will. I think that there's still going to be some process that we're not going to be able to do digitally somewhere.
That's kind of what I was thinking too.
Yeah, like there's the mortgage industry is so huge. So I've only been in it for a couple of months, but I'm sure that there is something somewhere that needs to be in paper. But we are definitely, as of right now, moving in the direction of everything being digital.
We even have a process at Acuity that I've been trying to get in contact with my manager about it, because it's always done on paper and we don't have a new way of doing it yet, even though we're all working from home. And I asked like 2 days ago and I still haven't heard back. So I don't know, there's some things that just can't be taken off.
Yeah.
Well, we're still using COBOL in a lot of our business processes. So I guess these things take time.
Right? That makes sense.
Actually, it just probably shows that COBOL is a good language.
That too.
Other questions? All right, who's next then? Any takers before I just start?
I can go.
All right, go ahead.
Yeah. Yeah, everybody can see, right?
Yep.
Mhm.
Yes.
Yeah. Now, it's I will talk about the blockchain. Then let me start with first. The first blockchain was conceptual by person known as Satoshi Nakamoto in 2008. But before that, the first work on cryptography chain block was done in 1991 by Stuart Harper and Scott Tornetta. Then then they were something they were not able to done, and they were improving the efficiency of that, but they were not able to done completely. So we can say that in 2008 Nakamoto improved the design, and it is more important way using hashcash like method to timestamp block you without requiring them to sign by a trust party. In August 2014, the Bitcoin blockchain file size contained records of transactions that leaves occur on the network reached 20 GB. In 2015, the size of grown to almost 30 GB, and in 2016 and 17, the Bitcoin grew to 50 GB, 200 GB size. The the ledger size has extended to 200 GB by early to 2020. So what is blockchain technology? Technology, something refers to a distributed ledger technology, makes the history of any digital asset unalterable and transparent using decentralization and cryptographic hashing. A simple analog and understanding blockchain technology is like Google Docs, but is way completely means it's way completely more than that, but it's like that. When we create the document and share it with a group of people, the document is not distributed instead of copies and or transferred. The creators a decentralized distribution change that gives everyone access to the document at the same time. Like we have talked that work of blockchain is divided into three types: blocks, nodes, and miners. Blocks, that means a data. The nodes, we can call it like node that can be kind of any electronic device that maintain copies or any blockchain, keep the network functioning. The miners create a new block every time the change through the process called mining. This is the step-by-step view of blockchain. As the user requests the transaction, the block is been created, then it broadcasts to the node to the network. Then all nodes are block, and it called be like data. The block is been added to the chain, and then it's the transaction get been verified and it's executed. The uses of blockchain technology. Now we can talk about the uses. Like blockchain is the version of developers who believe that the current banking system had flaws. The views banking act as a third party and proliferating transaction fees as unnecessary, and they scoffed at idea that payment validation and settlement could be up to 5 business days, and in the cross-border transaction they have like many fees, inside fees, and they charge a lot of fees. With blockchain, real-time transaction is possible, and while banks are left out of the equation, presumably reducing the transaction fees, and we can save a lot of money. And we can see the like if the transaction is done, we can see in minute or in 1 day. The first use is like payment processing and money transferring. Like there is a example of banks. Like one bank is from US and second is from Belgium. We this is like payment process like real what the money is been transferring. Like the most of the logical use of blockchain is meant to expedite the transfer of funds from one party to another. As noted, with bank removed from the equation and validate for transaction outgoing of 24 hours or a day. Like I said, 7 days a week, most transaction proceed over the blockchain can be settled within a matter of seconds. The second use is monitor supply chain. This is important chain, like it is basically possible even consumer that it can view the product from quality control and perspective, as like they can measure what is going on with the quality and where the product is being travel, like from one travel from the place from origin to the retailer. We can see from this blockchain also can comes in particular handy when it comes to the monitoring. By removing paper-based trial, business should be able to pinpoint efficiency which within their supply chains quickly, and as well as located item in real time. The third one is data sharing. Since the data sharing is most enterprise data goes unused, blockchain could act as the intermediate to store and move this data to improve a host of the industries. While still in this, it is early stage, the Internet of Things has more than 35 brand names participants, with Microsoft being one, offering it feedbacks. This is the medical record keeping. Like from blockchain we can keep the medical record. The good news is the medical sector has already been moved away from the paper for record keeping purpose for years, but now however blockchain offer more safety and convenience. Like it can we can store patient record, and the patient can access the data and strengthen the data, and uh, the law is also been there for safety wise of medical records. This is the survey for the industries that globally execute things been using blockchain development. This is I think 2019 one. The most is the finance service, they are using that, and the least is the entertainment and media. Now the application that are transferring the society is the most, that we can see that the finance industry is using most of the blockchain, like 49%. So there are like main three component of the finance industry are asset management, insurance, and payment. Asset management, it comes with the trade, processing, and settlement. It can be expensive, but it can be risky also. The blockchain layer reduce error by encrypting the record. Insurance, claiming processing, it been done very well. Room of error is being huge, so we have to be careful. It provides risk-free management. But the payment we can work with a peer-to-peer transfer, and main it worked for cross-border payment. In 2004, Santander Bank was the first bank to use this blockchain in the payment use. As we can see that there for the blockchain there is a risk, but there are people are like take closer look at the risk. So blockchain fall under two types, like permissionless and permission change. The permissionless blockchain allow any party without any vetting to participate in the network, while permission blockchain are performed by an administrator who can evaluate the participants on an entity on the blockchain framework. So they are like a standard risk, but we can similarly avoid that risk with the permission change. Thank you. Any question?
Questions?
Yeah. What did you find the most interesting about blockchain?
I found this one, the finance industry, like they are using most of the the bank name, some Santander in 2004. It was the first. I didn't hear the name of the bank, but it was the first bank that used the blockchain.
Cool.
I think it makes a lot of sense that the finance industry is kind of the first industry to really get into blockchain, and I found that in my research as well.
Mm-hmm. Yeah.
All right, anything else? All right, who wants to volunteer to go next?
I would like to go next, if that's
Okay.
fine.
Sure.
Okay. Share screen. Okay, so I was actually, can you guys see my screen just fine?
Yes.
Okay, so I was going initially for a completely different topic. I was researching, I did a week of research on how blockchain is helping the pandemic, and that's really cool. But I stumbled into blockchain as a service, and I didn't know that was a thing. I think back when I was looking to blockchain, and Mike was my professor, I didn't realize that they already have that type of servers, and it's being offered by big companies that is taking over the market. So, and if I think how blockchain is helping the pandemic is very cool. So if no one presents today, I highly recommend you guys to read. But I stick with this boring topic. So today I'm going to, oops, it's not moving. We're gonna give an overview of the blockchain, talk about the characteristics, the types of as a services that we have today in the market, the companies that offer blockchain as a service, but questions to ask before you go to develop a application on blockchain as a services, and the conclusion that we can get from that. And just a little overview, blockchain was created in 2008, was a group or a person called Satoshi Nakamoto, and is defined as a time-stamped series of immutable record of data that's managed by a cluster of computers not owned by any single entity. And to add to it, it allows information to be distributed but not copied. And cloud, in another hand, why I'm talking about cloud is it came up in the early 2000s, and the term it started in the University of Texas by Professor Ramanath. And basically, blockchain as a service is a conjunction of using blockchain technology on cloud infrastructure. And that's how it started happening in 2016, not long ago. So those are the types of servers that we have today. Just first to have a background of comparison. So the most common software as a service that the software is licensed on a subscription basis and centrally hosted. Usually you just own the data on you when you have something like this, and the company is in charge of the rest, of delivering versions of the software, of improving and maintaining it secure, of helping you with bringing from test to prod, things like this. And most common use are for CRMs, incidents, ERPs, and tasks, and even like for what I work with, like CMDBs and other management tools that we use on companies. And we have a platform as a service that most of you guys must use for application development. And it's very good for, especially if you want to centralize data that you can share. And we have infrastructure as a service that's part of platform as a service, but it's basically most offering virtualized computer resources over the internet. So then you don't have to spend too much with infrastructure. And we have blockchain as a service that can offer for you applications, tokens, smart contracts, as was said before, secure transformations and other areas. And that's basically the conjunction of the blockchain with the cloud. And though that platform, you can go in and you can start developing and having your own products there. But there are some things we need to keep in mind before we decide that we're going to become a blockchain developer or that we want to own an app developed by a blockchain technology. And some of them are that blockchain is distributed, digital, updated near real time, chronologically time-stamped, cryptographically sealed, irreversible and auditable, operates trustless, and has fewer third parties involved on this. And when I say operate trustless, I'm not saying that has less trust. I had a hard time with this word, but I know that's being used since I started learning it, that I didn't even know English. But it does not mean that it don't eliminate trust. It's just say that it just they do it's minimize the amount of trust that's required when using a single actor by using the entire system. That's basically what's saying, if that makes sense. And those are the companies that are offering this, and I was very surprised because Google was not the first. The first one was Microsoft with the Azure platform, and then we have AWS from Amazon, then we have Google, IBM, HP, Oracle, and SAP. Last year, the best ones that was offering the best service was AWS, Azure, and IBM. I think Google came lastly on this service, but it's catching up fast, I guess, because it's Google, of course. But there are a lot of questions, right, that we need to ask before we decide to go. Because, okay, basically those tech companies, they are working on provide business with all benefits of blockchain technology without the associated cost of having to build your own blockchain from scratch, which save a lot of money for people or even companies. Because if you're gonna have to create your blocks, your nodes, and have to go through that pain, it's almost impossible for you to maintain an application as well. So that's basically why they started these services. And but there's some questions you need to know before you go there and really figure out if you need to use that. So the first questions, I picked that out, the 20 questions. I picked 8. Is immutability need for the purpose of the case? So actors can change records. So if you need to choose something that you need to change records all the time, forget it. You don't need blockchain. You have a need to remove a record in the blockchain or correct a mistake. So blockchain technology is append only. So if you commit to mistakes, if it's an application like a CRM, you don't need it. You have more centralized systems that's going to help you best. Are there multiple entities involved, or are you trying to solve problems inside the organization? So that's, I think that's this question is more like these two questions here. So if you have trust already inside the organization, you're trying to use blockchain technology, it's gonna be kind of overkill if the trust already exists. Because if you think how expensive it can be to have blockchain technology, maybe you don't really need to have a blockchain technology. That involves too in a situation you have multiple independent entities that are involved in one project as well, or in one transaction. Is it important to know the humans or systems involved in the transaction? So blockchain are useful where you want to know the identity of the participants in the transaction. So if you want to make X look like Y, you should not use blockchain. And because it's very straightforward and transparent with the data that's appended there, how important it is for the system to be distributed. If you can go with a centralized system, just go with a centralized system, because blockchain, having distributed systems is very expensive. And that brings to the next questions: what are the performance requirements? You're not going to be able to develop a application game there, because it's expensive to support, and the transaction per second is limited as well. So it's not going to be like you can have Need for Speed running on that. So is there a good architectural fit between application being designed in the blockchain? So that's another thing. Like, are you going to be able to use append on blockchain there to manage your entire transaction? Is your other process that have involved on your applications that you're developing being really accommodated by the use of blockchain? So those are the 8 questions that I picked, and I thought that was very important for you to be able to analyze what is usable or not. And here I just put some examples of using, and I highlight 3 of them. It's payment processing and money transfer, which was talked already and it's most used today. Digital voting, which is very cool, because now here you guys vote with paper. In my country, we vote with computer, but I thought that would be much safer to have like blockchain. Medical record keeping, that I think it's probably going to be the next top coming up, so I'm not going to say anything about it. And tracking prescription drugs, which is cool on some cases too. And the conclusion that I had is that blockchain as a service is just the marry of cloud service and blockchain. And it was very useful for companies today to be able to use different technology, develop it, and create security within their applications. However, it needs to be evaluated before you use, because it's very expensive to build and to maintain. But however, it's also becoming very popular in the banking industry. I was looking Deloitte, they have around 8 banks that they have developed application infrastructure that's based on blockchain solutions in the United States. So that's really cool. And I forgot to start my time, but let me just show this. This is how Amazon managed blockchain is. So I was just curious about the price. They literally just see the demand per node. Then you can choose a server and go through the per node storage, where it to go. Then that's how you get the pay, like 10 cents per giga or whatever. And that is a different price between the environments of test or production. So that's it for me. Any questions?
Questions?
I have a question. Just yes, it is surprising that we already have so many blockchain as a service, but do you think they are just abusing the name? Because I think, say they have a blockchain in backend, but for implementation, that's a really not an easy thing, I think.
Yeah. So what was the question?
I just
Sorry.
say if there is anyone who is indeed using, for instance, like Amazon's blockchain, do you have any funding, like a well-known?
So here, like clients, for instance, that's what I want to know.
Yeah,
So
yeah, yeah.
yeah, so this is what I got from AWS, from Amazon. So that's some of the clients that they have. They're very big companies. I did not dive into what type of applications they were developing, but I looked at IBM a week ago, and they do have a lot of big names like these ones here, there. So it looks like they have a lot of people, and the test environment that they have offer is not that expensive. So I would imagine that people are playing around a lot with that, even though it's only a 4-year-old service platform.
Sure.
Yeah, but I was very surprised. I did not know that at all, that you could just come to this type of companies now and get blockchain as a service. That was very new for me.
Other
And
questions? Okay, well, who wants to go next?
Can I do next?
Sure.
Can I go
Sorry.
after him?
Nope.
Sorry, I can't.
No problem.
One question.
Camilla, can you? Okay, now I can share.
Somebody had a question. What was the question? Oh, no, no question. All right, go ahead, Blade.
Give me a second. Let me share my screen. All right. So my topic today is really similar to a lot of people talking about before. But mine talking about is the healthcare, especially the data sharing part, which Camila already mentioned. This is one of the most promising application on blockchain. So first of all, as a tradition, that is a short explaining of what is a blockchain. I will skipping more the thing here because people already mentioned it and talking much better than I do. And I don't think I know really well because things like it's just a linked list, but it's distributed like in different computer or different client. And one of the things I think is, besides of outsiding what we know in the block, we have transactions, timestamp, hash, and verification, verifying nonce. And I think usually we will also put something else, just like a Bitcoin, you have a token for the Bitcoin, and something there still inside the block, and that will be the foundation for the data sharing. And then talking about what's the background of the medical records sharing, why it will related to the network, IT, or blockchain. One of the thing is ever since 1996, and because of the American Recovery and Reinvestment Act, and after that in 2000, Health Information Technology for Economic and Clinical Health Act. So it can pushing all the medical institution or the healthcare institution to using electronic health records, which is meaningful to increasing the effectiveness and affordableness, and also a security concern when how to making the healthcare in a better quality. But unfortunately, not every, even though most of the health records are in electronic forms, but it doesn't really reaching the purpose of those acts, which is in order to provide a really a better healthcare. Still, healthcare community doesn't share the data very well, and that is against the criteria of the act, which was initially being established. So let's see what's the problems of the healthcare and what the blockchain actually provides to solving the problem. So the first one, which is the healthcare, we usually, when you go to see a doctor, and definitely you got a lot of health record. But what if you go to a different doctor? What if you go to a different hospital? What if you even travel to a foreign country? How those healthcare records being transferred? That's really a big challenge. And blockchains providing a different way of doing things, unlike traditional, which is trusting the mathematics rather than trusting the human. Dr. Lim already told that is not the reality in our world, but that's, we hope this thing can solve it. Another thing is healthcare costs and the qualities of deliveries. And that is also, blockchain has some advantages over that. It has enabled better utilization, risk management throughout creating a holistic patient concern views, and that's it, blah, blah, blah. I will ignore that. And I think one thing which we usually concern more about is one of the tricky thing is, as a patient, do you think who owns your record? You, the owner, or the hospital or the medical institution? Most like it's kind of hard for you to get your medical record. Just like Dr. Littman, if he is asking for, say, give me all my record, perhaps he will be overwhelmed by the paper, and which means he didn't get anything. And also he didn't know how to use them unless he given to a professional. But the blockchain is kind of a way to share and control the data better. That's the idea of putting the blockchain into the healthcare. And also the privacy and the security, which also a bigger concern no matter what we're talking about, especially the personal information. And blockchain also is famous for its security. At least it's more resistant to attack, and also it has a better way of protection the data by encryptions and cryptography. Then let's go into the detail. Is one of the things we're talking about at the beginning is in the term which is called sorry, I cannot spell the word. So this is, in short, in translation, my translation is the ability to sharing data between systems. And it requires a secure network infrastructure, and it also needs to have a verified identities and authentication of all patients, and also need to have a consistency proof of authentication of data, which actually blockchains providing a good solution of that. The next thing is security, which actually what blockchain can provide is audition, and also you have patient can have a better control of their records, and they can give access to people who they would like to through blockchain, and also it's become more transparency and also better for accountable, and also preventing the records from changing. And then the distribution make it distributed manner make the blockchain more resistant to attacks. And the next thing is the saving for the cost. First of all, and people already talked about it before, is as we can see, saving the data, no matter it is physically documented or it's on the cloud, it's a investment on the safe safe storage is really high. And the next thing is it's using blockchain can making the connections easy, and also as also we talked about before, the smart contract can make it more automatically. Then you can also saving some money on human force. And then the next one is the fraud, which is the same as both the insurance and the mortgage. Every industry lost a lot because of the fraud. And blockchains, because it has the whole full, completely history of the transaction, so it knows who, when, and what they did. And I also will taking that this one, just like Camilla mentioned, there is already a blockchain system called the NuCal, which is helping to tracking the prescription of RPT. So that's really a good thing which could be useful in the real world. And but blockchain is also having some problems, even though it's can leverage the communications between patients and medical entities, but it's also a problem is what about between blockchains, and what if there are different medical institutions using different blockchains, or if it is trying to using the different mechanism blockchains. Another thing is data storage. Data storage is say we won't really be able to storage everything as Bitcoin doing storage on every node or every block. We need to find somewhere to storage the medical record, and how to storage and how to retrieve it safely is also a challenge. The next thing is scalability. As we know that, which Karan already mentioned, the Bitcoin, the whole chain is getting larger and larger and larger. Also, the performance will go down, and the security will become harder and harder. So how to deal that when the scale is getting large? Then the next thing is the vulnerability, which is say Bitcoin or crypto currency. They are built on encryptions, but it doesn't mean it's not vulnerable to attack. If you can attack most of the world of the network, means those things are useless. So also there are some human errors, which has I think someone already mentioned that what if we make a mistake there, and what it will make the transaction really hard to correct because it's immutable. Then the next thing is about the security and privacy, because Bitcoin blockchain is kind of open to everyone. How to secure it is also a thing to think. The next one is the data ownership, which is when you authorize your data to someone else, how you can prevent it from accessing again through a blockchain. That is something you need to be think about in technology. And the last thing is the data blocking, which is saying in default, companies don't want to share data because if you think it's valuable enough, you don't want to let your competitors know, or you don't, if it's something that's secret, you don't want public to know. But in blockchain, how we preventing the data blocking happen, because it will preventing the whole system going. And this is a small example for someone who made about the data sharing as a technology, as an architecture, which is, in short, he considers some of the challenge I mentioned before, which is related to data storage and vulnerabilities and the data ownership. And the last slide I'm sharing is in 2018, and in the magazines for blockchain in healthcare today, which take about 10 points, which in what it will be the future kind of thing in in the next few years. There are a lot of interest in here. I think one of the thing is the supply chain. Like we probably can document everything in supply chain on with blockchain, which will be really nice. And we know, okay, for instance, like nowadays we know this face mask, where does it coming from? Where does the material coming from? Is it from some nowhere in India, or is it from somewhere, some storage in America? And also the education of stakeholders will use the case of blockchains etc. adoptions, which is similar to Camilla mentioned. Like we do have a lot more and more people understand, like think about how to apply in blockchains. So this is my last slide, and hope you enjoyed. Any questions?
I was reading about
when you started these last slides.
Well, what are the hippos doing?
You can guess.
Blade, I was wondering about like someone else brought up before too. I was wondering about like, well, what do you do if you have bad data in the blockchain? Like, you know, it's immutable, so you're not supposed to go back and just change it. You know, the hashes will all freak out and so forth, unless there's a mechanism.
Frankly speaking, all the documents I mentioned almost putting the immutable as the first challenge in blockchain applying on the data sharing. Because when you put the data there, how you have been changing that is always a problem. And I didn't really see anyone who given a solution, but I can think of which is, just as I mentioned before, there is one example I mentioned. This guy who designed this system, he is not storing the data inside the blockchain. Otherwise, he stays like storing some of a hash code for the almost like offsite distributed file system. So it's like I'm saving a file path on the blockchain. So I'm not sure if this is a way that he get over in that. So your storage code rather than the data itself. So you change the data, doesn't matter when you're changing the kind of the name of the file.
Right, and that gets back to like you're now centralizing it somewhere. There's like one actor who controls it. Maybe.
Yeah, it seems like you have to have hybrid it, not fully distributed to everywhere. That is things like the sensitive data. They have no other way to. They have a way to centralize it.
I read one guy who said like we can make them like accounting ledgers, because you know you put in plus for adding money and you minus for taking out money, and then some of the database designs I work with, they make what they call repeating tables.
Mm-hmm.
So if you think of a row in a database like object oriented, each row is an instantiation of an object. And what you can do is you can make the same row and instantiate it a number of times, and you kind of have a method to say this is the latest row, so therefore this is the authoritative row. So you can add it on after to correct it. And I think they were saying two things. You could like try to do a ledger thing in blockchain, or you could make it, if depending on how the data or transactions are architected, you could architect your payload inside of the block so that you know, okay, this supersedes a previous ledger entry.
I see. I mean, I think that is definitely a challenge, because I see several people always putting that in the first challenge, because apparently they think it's when they find a way to get over, then it means it will contradict something inside the concept of blockchain.
I will tell you as a DBA though, when you have tables that do that, where instead of just say one row to control the entity, you're going to do multiple rows, so you can kind of see its history as well. You're going to run out of storage more quickly, especially.
That makes sense.
What is going to happen if, for example, if I have serious problem, and I went to overseas,
Yeah.
and I meet a doctor, and through the blockchain, and his degree says so much. He has PhD or experience hold, and he has put the fake degree and fake experience, and I meet him, and
Oh,
he
you mean
treated me. I will be
I
dying.
think that's a different story. I think the scenario talking about is you are an entity and all your records is behind a blockchain. So whenever whoever the doctor is, if you authorize him, he can get all the records, not through the other hospital, but they can directly getting through the data sharing system over the blockchain. But for the verification for human, I think it's another type of usage of blockchain. Say you probably can say everyone's education record and his profile can all be accessed through blockchain, just like resumes. I would think that's a different story, but it is possibly can get over through the blockchain.
Yeah, I understand, but there are the deception in this world, and some kind of verification must be done. Who is experienced and specialized, had good degrees, other will be could be a big problem also.
There's another thing which I just coming through. If you, I don't really have a really good example, but I would say when you see any dramas related to medical um, 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 cases, it's really common to say when one doctor sees the prescription of another doctor, he will give a different opinion based on his experience and what he saw. I think the case is it really depends on the person who reading the record rather than you cannot really control that. Just like you cannot go to hospital and say, I don't trust this doctor, I want to go to someone else. That's the only choice you can do. But I don't think this is really related to what my thing is.
Okay.
I'm not really sure if I really understand what you mean, but I think
Yeah, that you say, yeah, it's true. That depends. Yeah. But anyway.
All right. Anything else?
Yeah, I was going to ask one more because
Sure.
Blade had the interesting point about fraud. And I was wondering, like in these systems where you still have to interface with someone who's going to do like data entry into the blockchain, because we always tout these out as like these will be great mechanisms to reduce fraud. And as they've been rolling them out in places like Africa where certain governments are extraordinarily corrupt. They thrive off of corruption. That's the way the politicians get ahead. And Blade, do you really think that if someone is motivated enough, be it a politician, whoever, that we can use these systems to get around them gaming the system?
Well, I think I'm not really sure if this is the same concept, but I definitely have an idea of that. I think the fraud on blockchain, which we understand, is just taking Bitcoin for the network, for example. You have to be acknowledged by 51% of other blocks. Then otherwise, whatever the transaction will not be valid. I think it's based on this understanding for that. So for instance, if America have say 2.2 billion people, then if everyone has agreed that I have to get 0.1 billion people to say, okay, Blade got $1, that's it valid, then I got $1. Otherwise, if I don't get enough number of people, then no one will think that the $1 I get is real. So it's the same case if say African country like the politicians say, okay, we'll just say we have we suddenly say we have $1 billion. Then if the whole world say just like all the 7 billion people, if not like 3.5 billion people agree with that, then what he said is not valid. I think more or less like fraud is something built in behind to determine the thing is true or not. And this is done by the majority of the terminals on the blockchain. That is what my understanding of how blockchain preventing fraud. But if I think it's really complicated. Just like money is simple because it's just a number. But if you really saying of fraud on the medical record, that will be really challenging. I don't know how it will be established. Maybe in artificial intelligence can help. But I think that's a similar thing. You should get the majority of the other blocks to agree that the change is valid. Then that's a way to prevent fraud.
Yeah, and thank you. That's a good answer. I think it's probably like another one of my burning questions about this, because some people seem to talk about like this will solve the sinful heart of human beings, which as a Christian, I don't really believe that we'll solve this with technology. But it's more like, you know, say Medicare fraud, which was a good point in your slide. Like if a doctor in the United States, a lot of doctors, not a lot, but many doctors game our system. And if they still are going to throw their transaction in bad into the ledger, I don't know how the 2 million other nodes are going to be able to validate that. You know what I mean? That's not really the point of validation. So, but anyways, Mike, that's another one of my burning questions is like, will this really get rid of like fraud of that kind? And I don't think it's designed for that.
I think if you're taking the pandemic, for example, if the majority of Americans says, no, the pandemic, the disease is just a lie, okay, then the fraud is will not work. We cannot anti the fraud. Even it's real, it's really based on everybody behind. But the blockchain, I think, is really has some. It's really optimistic about the good part of the honest part of human, rather than the if everyone is a liar, then it won't work. So it's based on the math rather than human.
I think when you talk about the Medicare frauds, from my experience, most of the Medicare frauds, they're related to billing process. Yeah. So the billing process not exactly has to do with the record for the, you know, the data records for the patients. So there are two different processes. There are a lot of money lost with validation, and I know that Medicare also lose a lot of money with data validation. But I think the fraud has more to do with the billing process than the actual data records.
So having a transparent process like this where you could see start to end, this is how it worked, would actually help.
That is why I put these slides on, because it reminds me what the paper I read, the blockchain, how they're preventing it is it listing all the transaction history, and it's possible to trace back what's wrong with it.
Well, that's interesting. Thank you, Priscilla. So it's really not an issue with people falsifying the record so much as somewhere down the process they figure out a way, a loophole or whatever, to get more money than they ought to.
Yeah, a physical person, it's hard to, of course, it's possible to falsificate, for example, a prescription. And this is a kind of fraud too. But it's not that common. It's more common billing process. So actual companies that, you know, make all this fraud and steal lots of money from the government. But
the prescription still is an example for the fraud, like decreasing the fraud, because when the paper I read is people made this pioneer system, and it's helping to say, okay, how these doctors subscribing medicine and how this patient receiving medicine. And if you're keeping the tracking, then you will know, okay, probably this doctor is like subscribing too much on his habit. I'm not sure, probably it's not exactly same fraud we're talking about. Someone induced to putting that in the same idea of preventing frauding.
Yeah, there are tons of kinds of different frauds in the healthcare system, mostly an expensive healthcare system like here in the US. But prescription fraud it's one of the types. But for Medicare, as far as I know, the majority is for billing process, not exactly prescription. So you can have a doctor that is actually selling prescriptions, so he's prescribing drugs that don't need to be prescribed. But most of this process in almost every state, it's very electronic.
Mm-hmm.
We have like a very few states and specific insurance that still prescribed like on papers or things like that that are easier.
For sure, that is why it's really a thing we need to, like, the whole medical system should be trying to improve in the next 10 years.
Oh, there is a lot to be improved in the healthcare system. It's just one.
Thank you. Any questions?
I Blade, one question.
Yeah.
What do you think if there is a chain of people who can be in that system who can verify the people who are fraud or not? But the thing is that if there is chain of people be there that can become a centralized rather than decentralized. What do you think that if their group of people will verified and who's a fraud or who's not fraud? Good or not?
I think the real thing, if you're really saying blockchain, I think there should be some people should invent either algorithm or technology behind to do that. If you really think about blockchain, verifying either the client is true or the transaction is true should not be done by human, because first of all, it is costly, and the second, it is against the automatic nature of the blockchain. But of course, in the real world, potentially they should have someone to monitoring all the transactions of blockchain. So I have no really a good idea, because everything right now is still very new, and definitely there is someone already doing that, but it's not mainstream so far. It's just starting.
Okay, thank you.
Anything else? All right, who wants to go next? I think wasn't there a previous volunteer?
Me? Can I go?
No, anybody but Priscilla.
You're so mean.
All right. Yeah, I guess you can go.
Thank you. I'm gonna share my screen here. Okay, can you see my screen?
Yep.
So, as usual, I will talk again about the healthcare system.
Sorry, I steal you first.
I always go for something related to healthcare system, right? So I will try to don't talk as much as for the same things that Blade just spoke with us. So let's go. Blockchain will do for business what the internet did for communication. This is a statement from Sam Daly, a very recent statement that I thought it was very powerful. And I also got this from the MIT. The whole point of using a blockchain is to let people, in particular people who don't trust one another, to share valuable data in a secure, tamper-proof way. Something that we're just talking about in the beginning, how we can not have people in the process to trustful. Blockchain applications in healthcare. There is a massive opportunity for the blockchain revolution to lead a digital transformation from medical records to pharmacy and supply chains, and the whole medical chain in general. And why blockchain? Healthcare data can be created, copied, and modified faster than ever before. And if data is the fuel behind more efficient care, blockchain may be the vehicle to get us there. Today, healthcare systems, they're losing about $300 billion every year in poor integration. And when I say poor integration, this money is lost basically because with data that is not being well validated. So not exactly fraud, but poor validation in general. In its pure form, blockchain would offer healthcare a safe and secure system to share data more efficiently. And for healthcare, the blockchain can optimize real data through a vast connectivity, providing a new way of sharing, analyzing, and verifying information. So here we have some applications of blockchain in the healthcare system. We have here electronic health records. That is the topic that Blade just told us, but we also have medical supply chain, which is the whole process for drugs, for example. So we have some drugs that need to be kept in a certain temperature. It's not just that you want to know where it came from, but you also have to make sure that it's being kept in the right temperature or the right condition. There are tons of different conditions that drugs need to be monitored during their whole life cycle. Neuroscience studies, pharmaceutical medicine, telemedicine, and healthcare, which is the new trend. We're just starting that in Brazil, so it's a topic that I'm very interested about there. That we're starting to authorize the healthcare. You know those apps that we have here, where if you have like something simple, you can just consult an app and get a prescription for a pink eye or something like that. You don't actually need to go to a doctor, and it's way cheaper. Genomic market, clinical research and development, and biomedical development. So for electronic health records, as Blade said, we had tons of records that need to be kept every day. Different doctors, different doctors' offices, actually, they don't necessarily have the same system, so sometimes it's hard to communicate. So I'm sure anyone here who went to a doctor, a different doctor, had to fill some papers that you already filled in a previous doctor, and they ask you about your records, and if you have any medical condition, and you have to say the same thing over and over, because sometimes they cannot just get the information that you have. So there's a huge amount of healthcare data being created every visit to the doctor's office, but every doctor has a different way to store them. Medical supply chain, blockchain-based approaches offer the potential to track the whole life cycle of drugs and medicine down to a single dose, from making and distributing products. The secure digital marketing of pharmaceutical products to provide a secure and reliable track of all these products. as I said before. Clinical research and development. The healthcare industry will be more modern and with applications and integration of blockchain, artificial intelligence, machine learning techniques, and blockchains provides a workable solution to these problems. It's easier to keep this data connected. So if you have some, for example, if we were studying certain disease and you have tons of variations of medicines that can maybe help with something here, but also cause another problem there, and how to connect all this information about a virus or anything, it's easier to connect them through blockchain. Genomic market. Human genomic projects are generating a large volume of genomic data that is extensively used in the field of biotechnology and medical research. So blockchain has emerged as an appropriate and contemporary solution for storing and exchanging genomic data with safety and security. Same as research and development, the way to connect those topics is easier through blockchain. And also, it's good to mention that all this data has always to be secure, because for every research or genomic project, you have actual data from actual people that cannot be available for anyone to access easily, of course. Pharmaceutical medicine, the pharmacy industry introduced new and potential medicine and drugs with contemporary research on various health conditions of patients to provide appropriate medication in time. So these new medicines, they're coming every day, and it's a huge volume of new drugs that are being tested and that are related to other drugs that are already cause certain issues. So all this data has to be connected. Neuroscience studies, the same dynamic that blockchain connects all the research that I just told you guys about. It is also a good way to connect neuroscience applications such as brain augmentation, brain simulation, and brain thinking. Storing all that brain data requires security and reliability, and blockchain technology provides that. What are the companies saying about it? So blockchain is already being used in many companies, and it's being also implemented in other companies. So for example, in Estonia, it's a small country in the Eastern Europe. You guys might know better than me. Estonia, I think this is how we pronounce in English. So they began using blockchain technology in their healthcare field in 2012 to secure healthcare data and process transactions. Now all the country's healthcare billing is handled on a blockchain. 95% of the healthcare information is ledger-based, and 99% of all prescription information is digital. This is amazing. Of course, Estonia is a small country, so it's obviously easier to control all of this. My timer. But it's amazing that they already have the whole system, the whole country, sharing information and being compatible. So I have also data here from Humana and Optum. They're partners from the company that I work at. And we get data from Optum, and we send data to Humana every day. And it says here that Mike Jacobs, which is a senior engineer at Optum, he says that blockchain will be the key that unlocks barriers to healthcare data sharing and ultimately enables an industry-wide shift to value-based care. And the CEO from Humana says the blockchain will become the next big healthcare technology innovation, particularly as it relates to payment and payer contracts. For example, a situation where a health plan and patient are dealing with contract, and the blockchain can automatically verify and authorize information in the contractual process. So you see that here they mention about unifying the billing process and the actual health record, electronic healthcare records and research. And that's it. Anyone has any question?
Questions?
Not a question, just curiosity. And why do you always pick up healthcare systems when covering the presentations?
Because I work with healthcare data and I'm still learning, and I take every assignment as an opportunity to dig in something that I actually want to learn.
Okay.
So, and to be honest, it's easier for me to talk about this than about other topics. So I pick what I have more interested in, and then I ended up reading more articles and doing a better job, I guess. Any other question?
Hey, you want to know what's funny, Priscilla?
What?
Is because of the timer this time, my phone did not run out of battery life.
Ooh.
How long your presentation? You were actually good on time.
Did you hear my alarm?
I did hear it. I'm proud of you.
Yeah. That's a secret to go, like, I'm gonna tell you guys, to go right in the middle. So some people already explained what the basic topic is, so I don't have to go over again. And this is my trick to don't go over the time.
Any other questions? All right, very interesting. So who wants to go next? I like the healthcare topics.
Me too. I don't have a chance to talk about the
yet right now.
yeah, right. We don't have chance to talk about the validation. I remember you said about the validation in the beginning, but maybe after all presentations we're gonna talk more about that. I thought someone would ask something about it, but
All right, who wants to go next?
I'll go.
All right. Is that Galib or is that Ishtiaq?
It's me, Devi.
Oh, Devi.
Yes.
I've already blocked you out because of the haircut.
No. So you can see my screen, right?
yes.
Yes.
Thank you.
Yes.
So my topic is blockchain and quantum computers and how the quantum computers are dealing with blockchain and all. So I'll just start with the main section. Instead of discussing what is blockchain and all, I'll directly go into the topic. So I'll start with what is the current state of blockchain in the market. So in 2018, PwC's survey of 600 executives from 15 territories says that 84% of their organizations have at least some involvement with the blockchain technology, and 45% believe that blockchain trust is not adaptable yet, and 30% see that China as the rising blockchain leader, and forecasts say that blockchain will generate an annual business value of more than 3 trillion USD by 2030. And it's also possible to imagine that 10% to 20% of global economic infrastructure will be running on blockchain-based systems by 2030. So here is how the blockchain project stage is it's in 2018. So you can see here 14% of the organizations still haven't adapted the blockchain technology, and 20% are still in research stage, and 32% started developing in blockchain technology, and 10% went on pilot mode, and 15% are projects went live with blockchain technology, and 7% got paused for various reasons we don't know. And in this 7%, most of the US organizations are included. So coming to, how blockchain is changing the business. So you can see here the graph where 46% of the blockchain technology is used in financial services, and 12% in industrial products and manufacturing, 12% in energy utilities, and 11% in healthcare, 8% in government sector, 4% in retail and consumer, and 1% in media. So here there are few significant shifts in business landscape with blockchain technology. These are listed as tokenization, initial coin offerings, enterprise software platforms, and new industries. So tokenization is nothing but it's a representation of real or virtual assets on a blockchain, which is now spreading to raw materials, finished goods, etc. And you can see now you can now represent on blockchain almost everything businesses can do. Initial coin offerings is in where a company sells predefined digital tokens to the public. This way, they are funneling the billions of dollars into blockchain platforms. With this initial coin offerings, organizations are able to raise their profits to 13.7 billion in 2018. And in enterprise software platforms, human resources and customer relationship management are being implemented to integrate blockchain. And Microsoft, Oracle, SAP, and Salesforce have been announced blockchain initiatives. Here you can see another graph where the territories list where the state countries as blockchain leaders. So in 2018, US was almost 29% as the main blockchain leader, but by 2021, it got reduced to 18%. And now the China is with a rise of 30%, it has become the blockchain leader. And the reason for US stepping out of this, of the competition, not stepping out of the competition, but it's planning something big, which might include one of the key issue, that is quantum computers. Let me discuss about that here. So, US is currently preparing for for quantum computing against with relation to the blockchain technology. 1 minute. So, the biggest danger to blockchain networks from quantum computing is its ability to crack the traditional encryption from the blockchain. Quantum computing is area of study focused on developing computer technology with principles of quantum theory. So it has enormous power, processing power to perform tasks using all possible permutations. So in quantum computing, a threat to blockchain is a quantum computing threat to blockchain. So the short answer is yes. So present day quantum computers might not be a threat, but using the quantum supremacy in the coming years, the blockchain technology is at risk with that sort of fast processing calculations. So what crypto algorithms and blockchains are threatened by quantum computing? So quantum computing might become threat to all blockchains that rely on ECDSA, which is basically elliptic curve digital signature algorithm, including Ethereum and Bitcoin. Bitcoin is currently using this ECDSA algorithm. What does this ECD algorithm does is it just creates a keys under public key cryptographic system that is used to sign for transactions and in most blockchains. The system allows to create a random 256-bit private key and deriving public key from that. And this public key can be shared with the third parties. Quantum computers can break this mathematical link between the public key and private key, which are hard to break by the traditional computers which we are using now. Because the current computers which we are using draws more power to break that, and it might take many days or months, So researchers say that this ECDS is used by Bitcoin is at risk and can be easily broken down by quantum computers by 2027 because the supremacy is not yet achieved. Even though supremacy is achieved by Google, they are under practice. But we can, so considering this this kind of issues with the quantum computers technologies, and as a risk for the blockchain technology, what the government organizations are thinking that why not we can use quantum computers for developing security for blockchain algorithms. So these approaches included two types. One is quantum resistance layer upon the existing blockchain algorithms, and another one is quantum resistant blockchains from scratch. It means here they build blockchain right from the scratch with the help of quantum computing. So there are already few projects that are implemented the second approach, which is quantum resistant blockchain from scratch instead of using this resistance layer over the current blockchains. So there is a Swiss-based foundation which started this, and it's called a QRL, Quantum Resistant Ledger. So it went live in last June. It uses new algorithm called XMSS, that is Extended Merkle Signature Scheme. It's a hash-based signature that is not vulnerable to quantum computers. So currently, US National Institute of Standards and Technology has drafted an approval for this, saying that you can use this, but with a few modifications, because this algorithm might be misused. So you need to make few modifications to this as per the standards of NIST. So then it will be approved completely and can be released as a live version. So there is a similar hash-based signature scheme called LMS, Licton Mikali, which is way more advanced than this XMSS. So apart from these two algorithms, NIST has almost received 80 submissions to get selected as best post-quantum cryptographic algorithm. So these are post-quantum cryptographic algorithms because quantum computers are not live yet, they are under testing. So with these security and threats, can we say that, so with this security and quantum computer security on blockchain and its threats to blockchain, can we say that Bitcoin have an issue with infrastructure? Might be, because what Bitcoin does is its algorithm is ECDSA used for signatures, and while its hash-based function is used in block creations. So block creation doesn't pose much threat with quantum computers, but ECDSA does. So blockchain should need to work with quantum computers resistant layer, or again, it should build from scratch for Bitcoins. So to use quantum resistant blockchains, all the blockchains nodes should be used by quantum computers, which requires a quantum network to connect these nodes, which might take significant amount of time to be implemented because it's a quite robust approach, and it's still under development. And it is necessary to develop quantum blockchains before quantum computers take over, because the current technology, it is not possible to develop, before quantum computers are fully developed, we can't develop a algorithm which can be used on that. So it should be done simultaneously. So that's it from my end. Any questions?
Questions? Nothing? Got nothing? All right, who wants to go next?
I'll go next.
All right, give me about 3 minutes. We'll take a quick break.
Okay, perfect. Can you guys see my screen?
Yep.
Sure can.
Yep.
Okay.
No problem. Yes, I can.
All right, I'm back.
Should I start?
Yep, go ahead.
Okay. So today I'll be talking about nano blockchain technology, basically cryptocurrency, a digital money for the modern world. So Nano is a decentralized, sustainable, and secure digital money focused on addressing the inefficiencies present in existing financial systems. It is uniquely designed to provide simple peer to peer transfer of value. Nano empowers individuals with the most efficient and accessible digital money possible, connecting them to global economy with minimal impact. Nano provides an intuitive experience that feels like digital currency should. No fuss, no fees, no waiting. This is what an accessible and easy to use digital money experience should feel like. Talking about the advantages of Nano, so it is easy to use and feeless. Nano is simple and easy to use by design. By focusing on transferring value as efficiently as possible, the Nano network is able to offer fee-less transactions and provides options for users and services to easily access the empowering and cost-saving qualities of digital money. It is also eco-friendly because as the world continues efforts to reduce pollution and energy consumption, many digital money networks have restored to wasteful designs to secure their networks. Nano is smartly designed to address this issue by not relying on power hungry mining for security, but instead uses a lightweight and efficient consensus protocol called Open Representative Voting (ORV) for minimal energy usage. It is also instant because digital money should be quick and easy to use, whether buying goods at a store, transferring money across borders, or making payments online. Nano transactions are completed in under a second, so we no longer have to wait, and these are fully settled payments on the network. Business no longer have to wait for credit card or bank network approval. So before looking on how Nano works, let's just watch this video.
Banks have been our trusted financial middlemen throughout history. They offer a secure place for our money and relatively easy access to it. However, with bank fees and slow transaction times, this comes at a cost. But what if buyers and sellers could securely transact with each other directly without the need of a trusted middleman? This was the driving force behind the early digital currencies. Complex algorithms combined with cryptography and a public ledger meant that banks were no longer needed to verify transactions. Yet these currencies are far from perfect. Transactions require a process called mining, where computers compete to solve complex equations for the reward of newly minted currency. But as the transaction ledger grows, this process becomes increasingly slow, inefficient, and expensive. Introducing Nano. Nano utilizes an innovative technology called the block lattice, which works without a mining process, resulting in transactions of any size being processed instantly with no fees. There's no limit to how many transactions can occur simultaneously. Nano is the digital currency designed to function on a global scale. Nano's vision is to bring digital currency to the masses. We are focused on creating innovative applications that put Nano at the heart of people's everyday lives. And this is just the beginning.
All right, so the Nano network includes a set of unique and efficient features to work. It is able to provide instant payments, which require very little energy and are easy to use and provide the scalability needed for true digital money. The structure of the ledger is called the block lattice and allows each account to have its own blockchain. Rather than sharing one single chain, everyone is competing to add blocks too. With this setup, only the account owner can add blocks to their own chain, providing security while allowing many transactions to occur at same time on the network. The consensus mechanism called open representative voting also provides useful differentiation from other networks. Consensus is reached through representatives voting on the validity of individual blocks shared on the network. The voting weight for each representative is assigned to them by the account owners and is in proportion by the nano in those accounts. Account owner can still use funds without restrictions as no staking is involved, and the representatives have no control over funds. They just get voting rights for them. For creating an account, uh, anyone who is interested in investing in cryptocurrency needs to create an account to perform any transactions. This transaction is basically the first one of every account chain and is created upon receiving the first transaction block. Account balance is the entire user data is being stored at user's account chain, which is actually quite benevolent as there is no need to store the amount of transaction. Now the verification process requires only checking the balance of previously sent block and the current one. The value of new block can go in either direction. That is, it can either increases or decreases. This actually increases the processing speed of the blockchain platform by downloading the high number of transaction blocks. Sending currency from an account to successfully send the value, the sending address needs to have an open account with some balance. It is also being noticed that once the transaction is performed, it can be rolled back. Once the transaction is broadcasted to the network, the funds would be deducted from the sender account and will be kept pending until the receiving party signs the block to accept it. The pending acceptance is also considered as spent, and sender cannot revoke the transaction once given its note. For receiving payments on Nano, to successfully receive the payment, the receiver needs to create an account and receive the payment. Once the account is created and broadcasted, then the balance is updated with the new value. Nano wallets. Okay, so the Nano ecosystem has a wide range of third-party wallets, with each providing its own unique balance between functionality and security. A list of featured wallets can be found on the Nano website. Pay with Nano page is the link. Trading with the Nano is currently traded under the ticker symbol, which is dollar Nano, and is widely available on many popular exchanges around the world. Uh, for anyone who is interested to trade with Nano, you can check coin market cap markets for Nano trading. Nano pricing over time. The price and value of nano cryptocurrency is soaring after its inception. Investors are taking this cryptocurrency seriously and investing money in it. The price of nano has hiked up to $4 by December 2018. After that, it has been seen that price of nano cryptocurrency is going upwards and there is no stopping to it. Currently, the gains have gone up to $33. Uh, it is evident that after its rebranding, Nano has come into limelight and crypto traders have started taking this cryptocurrency seriously. Future goals of Nano and its foundation. The Nano Foundation empowers individuals with the most efficient and accessible digital money possible, connecting them to global economy in a sustainable way. They plan to continue transitioning the level of responsibility they have over various components of the network to a broader set of business organization and individuals. That's it from my end. Thank you. Any questions?
Questions? Nothing? Okay. Who wants to go next?
Yeah, I can go next.
Okay.
So for confirmation, can you see the screen?
Yep.
Okay. So starting with the blockchain technology, I got interest in the tourism sector or the travel industry. So as we know that the global tourism market crossed 8 trillion USD in 2017, and it is like forecasted to 1 year growth rate of approximately 4.7 probability of increase in travel industry by 11.38 trillion by 2025. So it's a huge market, and many of the most interactive economic activities includes tourism. So the use of blockchain technology in tourism will help the expanding the sector more further, and it provides the essential benefits that I will be going to define in this presentation. So first of all, like we know that there are like more of the applications in the blockchain technology, and which one in tourism is like a decentralized payment system which we used for booking our air flight tickets and the other things. So in this, like the first step is in the flight bookings, where nowadays it got an attention with the many of the companies like Air Canada and Etihad Airways, and many of the other flight travel companies are using blockchain technology nowadays. So first of all, coming back to the generations first, like we used blockchain technology one, which is a Bitcoin, of which a cryptocurrency used and represented in the ledger system, and then extended to Ethereum, the smart contracts, that is the generation 2.0, where all of the Ethereums are peer-to-peer network of the computer hardware, and it's a type of protocol that is in which the operating system can build any decentralized apps, and that can be used to connect the each and every node over a large area of the network. So, and also it has the programming language capability, so the user finds it more enormous and easier. And where it comes like the third generation of blockchain, which is an ARC block here, and I got a node of here, like it provides some kinds of this an SDK for taking out for installing the nodes into one and making a dashboard, so that you can know which how many networks are you connected into, and what is the essential nodes that you are interested into, and what is the chain you are that is linked into. So these kind of all decentralized apps are used in ARC block. So and it is a open chain access, and it's a cloud-based access, and nowadays it is now used as an application module, so which is like much easier and much comfortable to the user when it compared to the Bitcoin cryptocurrencies or smart contracts. Considering the categories in the tourism factor, it has a broad area of blockchain which is to be considered and still is in process. So some of them I will be discussing is the customer identification and the baggage management. So before that, we will just see a short video.
We're surrounded by digital transactions, millions and billions of them. These transactions form the foundation of our society, and they're at the point of being revolutionized by a technology called blockchain. Blockchain is a decentralized encrypted database shared across a network of stakeholders where digital transactions can be stored and organized in a transparent, verifiable, and secure way. Information added to the blockchain has to be validated by consensus, accepted by all parties, rather than by one central administrator. This reduces errors, as there is no single point of control. Each block of information added to the chain is time-stamped. This ensures that the information is auditable and traceable at any time. Most importantly, blocks added to the blockchain can never be removed or modified, eliminating the risk of data tampering and fraud. Blockchain is a young technology, but it has the potential to disrupt the way business is traditionally done. At Amadeus, we're already investigating the impact it can have on the world of travel. For example, payments. Making settlements between different parties, like hotels, travel agents, and aggregators, can be an extremely complex process, especially across borders. Blockchain could streamline this process by reducing the intermediaries and the settlement timing, while increasing the overall flow transparency. Traveler ID verification. Today, travelers are required to show their ID at multiple stages of the journey, from booking to boarding to checking in at the hotel. Blockchain could make this more secure while simplifying traveler identification at every stage. Baggage tracking. Another challenge is keeping track of travelers' luggage, as it changes hands from airlines to ground handlers at airports. Blockchain will allow all parties to exchange information, even if they are not in the same alliance or related to the same segment, improving the accuracy of baggage tracking across the industry. At Amadeus, we believe we are only just starting to see the possible applications of blockchain in the world of travel. The challenge will be to continue to find where blockchain can add value. At Amadeus, we are uniquely placed to take on this challenge, working together with our partners and customers to embrace blockchain, making travel secure, simple, and transparent for all.
So this was the basic overview of the blockchain in travel industry, where the travel industry become more and more easable for the traveler, like not waiting for the queues in the line, and not doing the going to the middleman travel agencies, and not doing time waste, and all of the identity management and the loyalty programs and all the discounts that are being used into one consideration has been used by one technology called blockchain technology. So we need not to wait. The process will be very much easy, and as well for the baggage management, it will track the baggage, and they will put the sensor on the baggage, and our luggage will be securely and safely raised to ourselves. So now, considering the current trending technology and trending companies that uses blockchain technology for the for travel industries, one of which is open source and most top used by the today's world, and especially like Air Canada and also Air New Zealand and Etihad Airways uses this kind of open source tree, winding tree, which is a kind of application of just a minute. So it provides us, it's easy to eliminate the man in the middle and provides 100% service rather than, so what we do when we book a flight, and so it charges our fees, and all of the transaction has been processing fees, and also some interest rate fees, and like in the middle some hurdles are there. So all the hurdles will be removed, so that we can just connect to the travel service provider. So the goal of the winding tree is to provide minimal passenger fees and eliminate travel agents like the example are like Expedia and eDreams. And the other one, the other company like Cool Cousins, which is a travel app, it is used for planning our trip, like a trip advisor, or Make My Trip is an best example for it. So here also they are using blockchain technology so as to reduce the amount of planning process and giving you a best available planning trip for the vacation or for the business trip, or of like vacation for years or months. The other company which is more famous is the Webjet, which is used for the insurance policies, uh, for like adding assurances with the supply chain layers, uh, which is a distributed ledger, and the customer experience by recording all entries into the immutable ledger, and like the human errors with the booking, and reduces the layers between the sellers and consumers, and providing the better protection for your insurance policies. So this kind of signing and paying process for flight insurance policies has been very much eased with the Webjet technology, Webjet blockchain technology. And other one, the famous one is the company of Sandblock, which is high loyalty programs used for discounts for our vacation or a plan. So it provides more like a loyalty tokens, so that can be used as a real money, and we can redeem whenever we want for certain amount of time. And the other famous one is the Accenture, which uses now blockchain technology. Basically, they want to provide the more amount of data for those travelers who are very frequently traveling to and fro for their work, or for their job, or for their professional life, or any other certain reasons. So they designed to collect the information from the international travelers, and provide a flow of data between the travelers and customs agents, so as to ease the process, so that we don't have to waste our time in just doing processing every time doing luggage checking, every time doing boarding and all. So just we just come over there in the airport and board for the one time, and all the things are set. The last one is the travel chain token analysis, which is same as kind of the Accenture, but it uses the travel data and allow us to modify it, and keeping safe from the other nodes of the data in the blockchain, so that we are safe, and we feel secure. So it is also like a token analysis, it compensation with the travel service providers, directly linked to the customized tools, basically, so as to provide the delivering value for all stakeholders. So basically, all these companies uses blockchain technology. So my conclusion is like, now blockchain technology is in under process, and many of the companies are using it for finding more of the simple, secure, and manageable process, and also security based on the nodes that are used in the blockchain, which is a wide area. And the planning, how the blockchain works, we know, and like it is a kind of peer-to-peer transmission between, and it's a computational logic over the networks. So one node, if it gets disturbed, the others don't stop, they will do the work, and it does not, like, we feel secure overall. So basically, travel industry is the famous tourism industry nowadays. So I think blockchain technology will uh, improve more and more in travel tourism industry, as well as in real estate industry, and many kinds of other sectors like government sector, health sectors, and all. Thank you very much.
All right, questions?
Not a question, but I just thought it's kind of interesting every week when we have these presentations, how obviously they're all related because we have the same higher topic, but how like we just have our different topics. We had a lot of healthcare, we had the mortgage industry, the insurance industry, and I thought that was interesting to get into even the travel industry and how blockchain can even be used there too.
Kind of going off what Maddie just said, I guess I'm just kind of curious, and maybe you mentioned it and I just missed it, but what made you choose the traveling industry?
You know, answer the question. What made you choose the traveling industry?
Yeah, so I was basically like researching the blockchain technology first of all, and I got to know that blockchain technology is not only the one with the related to the insurance or related to anything that is the banking sector. So when I got to know that it is like on a marketing sector, it is like on the government sector, it is like on the many types of other sectors, which I got to know, like healthcare sector, which brother Blade also said about that in an operation way. So I think that I thought that there is an other sector where we and I came like 6 months ago from India. So when I got to the airport, when I done the process for the first time, boarding and checking baggage and all, I was so confused, and I was so and I came alone. So I thought there is some process where these things become easy. So I thought like there is some technology will be evolving nearly, which makes the things easy more. So I thought like, okay, so maybe tourism is the one. So I thought blockchain technology in tourism or in travel industry maybe the one that can be used. And also like Winding Tree is an example of the open source tree which provided less charges for the travelers and more types of savings that can be used nowadays.
Okay, thank you.
Thank you very much.
Anything else?
Litman, sir, I have a question for you.
Yep.
Did you try to cook steak again?
since what? Because I didn't burn myself last week cooking steak. I burned myself last week trying to install a vent system, so I could cook steak. That vent system is the super powered one is still sitting in the middle of my foyer waiting for a professional to come install it. I think a couple of you saw on Facebook me asked like the next day. My wife finally said, no, I can't do it anymore. So I had to ask a professional. So I got a couple of LOLs and responses. But so I'm still waiting for a pro to come out and install the heavy one. But I did get one that's about twice as powerful as what I had before. And I got that one installed. So I currently have a setup that will allow me to cook steak, but not necessarily create a bonfire and not get the house smoky. I'm working on that one. Hopefully soon.
Yeah, you went on a little break, right? So I thought you might be cooking some.
But oh no, I just ran to the restroom. But I did use 3D printing for that because the new one has a 10-inch by 3 1/4 inch duct that has to transition to an 11-inch by 3 1/4 inch duct at that I already have in my house. So I designed a 3D printed part that did that transition between the two, so I wouldn't have a bunch of air leakage.
Good for you now.
Yeah, so it was a good use for that. All right, who's going next?
I was thinking, why don't you use blockchain technology? Somebody will cook for you.
Well, I've been baking. Well, I like cooking. I'm actually a pretty good cook. You don't get to be my size and suck at cooking. Yeah, I just want to have the right tools for it. And frankly, if somebody would come out and install it and wants me to pay them in crypto, I would. I got plenty of, I've been doing crypto for years. I used to mine Bitcoin and Ethereum and all that stuff. So yeah, if they would prefer to be paid on one of the blockchains, I could accommodate. All right, so who's up next? Let's see, we got Seth, still has to go.
I think I can go. I just need to.
Is that it? It actually?
I believe it is. I just need to trim some data real quick. I use VPN for work, and I only have Slack on my workstation, and I jumped off and I can't get back into my workstation. So if you'll look in the chat for Zoom, if you can open up the Zoom chat app, I have a link in there I'd like you to go to.
Yep.
Is Alexis not going tonight?
Sorry. Beg your pardon?
No, she's going to go next week.
Okay, my bad. Keep going, Seth.
Okay, no, that's fine. And let's see, I gotta quick edit this. I just gotta truncate some data in the database real quick. I gotta restage this thing. Vote on this proposed now. Where are we getting this from? So yeah, if you can follow the link in the chat, post block, and I'm gonna share out my screen. And I bit off more than I could chew, so I don't recommend doing what I did for a presentation. My presentation is actually going to be more of a demo. So I will throw this up there. So my presentation is I found in one of the papers that I wrote for reviewed for the annotated bibliography was about simulating blockchain as a game to try to teach the core concepts to people. One of the big issues with blockchain, is we all know now that we've done the research and given our presentations, is that it's kind of hard to wrap your head exactly around what is blockchain, why is it advantageous, and why does it work. So a lot of people have been proposing the use of games to teach people how to do it. And the paper that I read is not what I'm following with my software program, which I'm still not sure if it'll actually even work. It is this guy right here, J. Scott Christensen. He has a professor in Missouri, and he wrote a blockchain game that he will take his students through just using Excel, and they fill stuff out by hand. And so I thought, well, I wonder if I could turn this into code and make a computerized version of this that you could, like when we're all in COVID-19 lockdown, that we could teach blockchain remotely. So that's what I've done. So let me log out here real quick. And Mike, I have a feeling this is going to run a little bit long, so I might get dinged all over the place tonight. Do you all see a screen like this? You can react, you can unmute.
Yep.
Yeah.
Mike, your username is mlitman, like you used to log into the computer. Your username should be the same as what you used to log into the Concordia network. I think students, you guys use your F00 numbers, is that correct?
Yeah.
Okay. So throw in your F00 number, and then the password is capital C, lowercase s, 568, bang, bang, or exclamation mark, however you'd like to call it.
Yeah, I'm in.
Okay, good. I will log in as well. Okay, and I need to get rid of some stuff real quick. So I think, let me just run some SQL real quick. Okay, and I want you to go away, Mr. Zoom. Truncate table, proposed block. Truncate table, block, vote. All right, let's take a look. If you can go ahead and highlight your address bar like I just did and hit your return key, just refresh the page. We should not be seeing anything. And then let me make sure we don't have anything in here. Okay, we don't have anything in here. All right. Yeah.
So we should use our Concordia credentials.
You should use your Concordia username.
Okay.
Put this up here. Put it on my screen. That's probably easier than this. All right, 20 username equals F00, whatever that is, and the password is going to equal CSC568 exclamation mark, just like that.
Okay.
And let me see if I still have a copy of it. Notepad. I might be able to tell who's logged in. All right. All right, let's see who of you are here. This may not run real fast. This is, so, interesting. Last 5 minutes. Beg your pardon?
Don't remember my user.
Remember your phone number?
No, I don't call myself.
You don't have yours? Okay.
That's
let
okay.
me- actually, I can get all of yours. Just a second. If you don't know what it is, I will look them up for you.
Actually, if I try to log in.
Sure thing. So Priscilla, just a second. Let me.
Are you able to see it? Am I there?
Does it
Never
look
mind,
something
I
like
found
this?
it.
You found it?
Yeah.
Fantastic.
Yes.
All right, great. So go ahead and log in. I think we have everyone set in. I used my power as a DBA and I got the class list out and I said, oh, okay, all these people need to be set up inside of here. This is a tool called Oracle Application Express. It's a rapid web application development tool.
Wait, sorry, what was supposed to be the password again?
Sure, password is coming up right here. So go ahead and get yourselves logged in. If you're logged in, can you do me a favor and react in Zoom? Give a thumbs up, clap, sad face, something. This is a web tool that if you work with the Oracle database, it's a very handy way to do rapid web application prototyping. All you really need to know is the SQL. If you want to get more advanced, it helps to know the procedural language of the Oracle database, which is called PL SQL. So kind of like Maddie was saying, it's really interesting that everyone's doing what their industry is. I did as well, all that in a much more technical level. Okay, good. I see some of you are in there. If you can't get in, we'll just go ahead and go for the sake of time so we don't have to stay up forever. And the point of this web application is to introduce people who are not familiar with blockchain to what some of the key components of a Bitcoin type blockchain would be. So one of the things that we have is we've talked a lot about blocks is we have the Genesis block. The Genesis block is the very first block in the chain. And I've set one up here and I have the chat message. Okay, nothing to say though. All right, let's see who else is in now. Do we have more people? Whoops. Oh dear. Oh, well, anyways, I hit the reload button. So we have the Genesis block. This block right here, what we're going to keep track of in our blockchain is we're going to keep track of step counts. So say our insurance companies, since we've talked a lot about them, like if you work at Concordia, we have a company called Vitality that we use. It's a part of our benefit package, and they want to incentivize you to get out and exercise. And if you exercise enough, they will send you Amazon gift cards. Stage of life I'm at right now, it's not something I really do. I lack the discipline for it. But say they wanted to keep track of that using blockchain, this could be a way for us to keep track of it using blockchain. So the way that blocks are added, as has been said repeatedly tonight, is someone will propose a block to the chain and then the peer-to-peer network will validate it. Tonight, we as people are the peer-to-peer network. So I am going to add in a proposed block. By the way, you've each been assigned a public key. This is your public key. Your private key is your phone number. This is to emulate the Bitcoin wallet because a Bitcoin wallet has a private key in it and then it generates a unique hash signature from that. And that hash signature is one way. So as has been said, when you generate a hash, if you change even one character, it's going to be radically different. So the point of having a private key is you have this credential that you can keep safe, and then you have this hash that you can generate from it to use it to sign things so people know it's you. So I will say that I went ahead and I did some walking on Wednesday. And I don't know, I'll say I did 1,000 steps. So I'm going to go ahead and add the steps to the chain. And if you guys can go up here and just click in the URL and refresh like this. Dr. Littman would know this. You need WebSockets, but I think with the cloud infrastructure that I'm on at Oracle, I don't have a way to do WebSockets to notify my pages of when the servers do things to event. So Ani knows about WebSockets. Yeah, WebSockets are good stuff. Okay, so this is the way it works. When we have a block that's been proposed to the blockchain, we need to validate it. This is what I was talking about with proof of work. I have emulated a proof of work concept for us to teach people what blockchain is. So the way that we're going to validate the block is if you go ahead and click the button, mine the block, hopefully you all get a little pop-up window that looks like this. Give me thumbs up in Zoom if you do. Lonnie's got it, Maddie's got it. Camilla, okay, fantastic. Eric's got it. All right, taking this from Professor Christensen like I did, the way he does it is we generate a hash. Now the cryptography between SHA-256 hashing is pretty complicated. So if you're trying to teach this to people, you don't want to do a deep dive into how cryptography works. So he's developed a simple way of doing it. There's a key concept. Does anyone talk about Nances tonight? I'm not sure if I heard anyone talk about a Nance being a part of the block. Someone may have. We have a Nance that we need to figure out. And with the Nance, we're going to generate a hash. And we're going to know that the hash is valid if it is divisible by 3. So what we have down here is we have 3 values that we have generated as a part of our hash. I generated the 65 from the capital W, the 87 from the A, and then the C is actually the last digit in my step count. And then what we need to do is you want to pop open the calculator on your computer right now if you have it. So pop open your calculator. We need to derive a hash that we can use to sign this block to prove that it's valid. Come back, calculator. That is divisible by 3. And the way it works, what I'm just trying to indicate here, is it's going to be some Nance value plus this column, and this column, and then the last 2 digits of the previous hash. This is the hash of the Genesis block. This is kind of the way that validation works in Bitcoin-style blockchains. So let's see, I have a better calculator. It's not quite as fancy. So for example, what I need someone to do right now is I need you guys to figure out if we were to take 12 and we were to add 65, 87, we don't have to add 0. What do we need to add to 164? And the Nance value that we're going to put in here, it can be 1, 2, or 3. I forgot to mention that. The value can be 1, 2, or 3. So do we need to add 1, 2, or 3 to this to make it divisible by 3? So let's see, are you divisible by 3 right now? You are not.
Yeah, add 1.
Okay, you add 1?
Yeah.
Okay, and so that would change our hash to 165?
Yeah.
So Ani, why don't you go ahead and put a 1 in and put in 165 into yours. And then click this miner figured it out.
Error occurred.
What?
Exact fetch returns more than requested number of rows.
Oh, hang on. I know what that means. See, that's what I was saying. I was like, ooh. Don't try to...
Just a heads up, I had already clicked that. Then I already added an on-sub 1.
Oh, is that why you did that? Okay. So that's why it's... See, this is very brittle code. So if you all come back, close the window, and hit this right here. Oh, I see. Okay. So you'd already added a block for us to validate?
I validated your block.
You validated my block?
Oh, he beat us to it. He put in 1 before I did.
Okay. And did you put in the hash value as well?
No.
Okay. Yeah, it's... Sorry, like I said,
you
this
gotta
was...
listen to the directions.
All right, let's go back here real quick.
To the punch.
Hey, he put in the 1,000 steps, and I gave him the benefit of the doubt and said, yeah, he did it. But actually, it should be okay since I put in nothing for my nonce, and it should not have modified the value, right?
No, because this is we're human.
node validators in this network, so it's not smart. I don't have any sort of validation hooked in. So let's see here. What tables do we have data in? So if we go to proposed block, we look at data. Okay, yeah, we've got yours, we've got mine. So let me just truncate this really quick. Proposed block. We'll start it over. And then let's see, what else do we need to truncate? Do we have block vote? Okay. Block vote, we're gonna truncate you. All right, and then in our wallets, everything is good. In our ledgers, everything is good. We just have the Genesis block. Okay, so by the way, this is how it looks. This is, we were emulating a Bitcoin wallet. Here's your foo number, which is private key. Here's the public key that we derived from this. There was no mathematics. It was just me mashing keys. All right, so come back in. If you can, expand the little menu off to the left, click the home button. Should refresh things. So no clicking buttons here unless I ask. I'm sorry, it is a brittle program. So I'm just gonna re-add myself in. Ani, if you wanna mine the block. Let us know when you have.
So I just add 212, 65, and 87, right?
Yeah, so it's the same value as before. So the nonce would be 1,
Oh,
and the
okay.
hash is going to end up being 165. 165 is divisible by 3 if we have, or it's not nonce, it's nance if we have a nance of 1. And the nances in Bitcoin, for example, these are the ones that are figured out. Is that what they're figuring out every 10 minutes, Mike? They're figuring out a nance to figure out the hashes, from my understanding of it. And they're computationally crazy hard, which is why you need a lot of processing power to do this. And probably why Dr. Littman has like an array of video cards doing CUDA stuff someplace in his house. Okay, have you submitted it?
Yeah.
Okay. So if you all click the home button, does something pop up like this in the vote?
Yeah.
Yep.
Okay. So just take any link and go ahead and click vote on proposed block 1. We're going to cast our vote. This is how a consensus algorithm will work inside of a blockchain. The nodes, the miner, or certain nodes, depends on the kind of blockchain. So we're going to, this is a public blockchain where everyone gets a stake in it. We're going to go ahead and say, oh, look at this nance right here, and look at this hash. So you would go through the math on your own if you were validating. You say, okay, this nance, when I add 12, 65, 87, gives me 165. Is that divisible by 3? You work it out and you say, yeah, that's divisible by 3. And you can go ahead and vote and say, did the miner figure it out? No or yes. I'm going to cast a yes vote. Go ahead and cast your vote. Let me know if you have. I'm going to click. I try to make these buttons without text so people wouldn't see it. Okay. So everyone voted yes. Everyone said this is good. This is the part where I fear that I may not have validated my code. Let's go ahead and say what you're looking for inside of blockchain is 51% or more of people saying, so this is unanimous. Yeah, that's what I thought. Okay. Where are you getting more data from? Yeah, don't rapid prototype for presentations. So reward ID is null, a miner is from block vote. Why are there 2 proposed blocks? That doesn't make sense. Data, proposed block. Oh, wow. Oh, okay, so a bunch of people went in and decided to add blocks in for step counts. So, oh, a bunch of people went ahead and validated the block. That's why it's not gonna work. How do I fix you? Yeah, so you got to program in good data validation to let this go. If we go to the proposed block. This way, I'll show you what the code ought to be doing. And I say proposed block. A lot of people submitted blocks to be thrown in here. Wow. All right. Well, anyways, I'm going to have to bomb out on my presentation because my code is not in the shape. What would have worked is I would have come here. I would have clicked accept the block. We would have come back home. We would have seen beneath the Genesis block, we would have seen block 1 added in with the steps, the person ID, the hash of the Genesis block in the previous hash column. And we would have gone ahead and seen a reward. We would have rewarded Ani with Bitcoin, or actually, I don't know, some sort of currency, and put her ID in there. And so what you would see is as the blocks build out, you would see this ledger that everyone has a copy of themselves in the peer-to-peer network, where we see people who figured out basically how to compute the hash and the nonce, and they get reward. And one of the things you could do, I don't have any, is you can go ahead and take a look and look at all the blocks that have my public key stamped on it, and I can see the rewards. And one of the things I was going to try to do is I was actually going to delete out someone's public private key entry so that they lost their ability to get their currency to simulate. This is what happens to you when you lose your Bitcoin wallet. Anyways, I guess the moral of the story is don't bite off more than you can chew, but that's what I have for you tonight. Sorry, I think this will work once I develop a decent prototype of it.
It makes you feel better. It is interesting to have an actual demonstration of it, even if you know, it was wonky going through the actual process of what how a block is mined on a blockchain is an interesting experiment to look at.
Thank you. I do appreciate that. Yeah, this is a plug actually for you, Mike. If you guys are looking for a good cloud environment to teach SQL, this is fantastic. This is a very, very mature web development tool. But anyways, because I started this yesterday and today, I didn't get time to architect my tables properly. So therefore, I don't have very good normalization. So when we get to things like this, where I'm actually inserting data into the tables, I'm allowing for duplicate rows where there ought not be. But if you ever want to learn Oracle, this is a great tool to do it. If you ever want to learn SQL, this is a great way to do it. And I think Dr. Wall would be pro for this because he used to be an Oracle DBA once upon a time.
Yeah, I think he'd like it.
So anyways, I'll stop there.
All right, any questions?
I'll put in the YouTube link if I can find it for you guys.
Question.
Yeah.
So eventually, then the hash we're typing should be divided by 3, divisible by 3. Mm-hmm. And is that the reason why you can choose a nonce between 1, 2, 3 to make
that? Is absolutely correct. If you have 1, 2, and 3, one of those is going to give you an integer that's divisible by 3.
That is making sure it will be divisible.
Yeah, and in a true let's see, I'll just share on my screen again.
So it's like a chicken or egg. Which comes first? Does the nonce comes first or the hash comes first?
In true Bitcoin, I believe the hash comes first, but then you got to figure out a nonce, and I can't remember what the nonce is doing. It's a SHA-256 integer, so it's like huge. If you were to put it into decimal, it's this just massive number, and you're padding that number with leading edge zeros. And I think you're taking it from a 256-bit number up to a 288-bit number. And you're trying to figure out a nonce that will give you a number that is less than or equal to that 288-bit number. Is that right, Mike? Am I in the ballpark of what you're trying to do?
Yes.
Because this is proof of work for Bitcoin. This is kind of what I was trying to show. Yep. And so like if for this simple illustration, if we want to make it harder, we would say, okay, we've added a number of blocks to our chain with 3, but you know, it's getting too easy. The computational power of us, because we're the computers in this instance, we're getting a little too used to it, so we need to make it harder. So then you would adjust the program to say, okay, now we need nonces that are divisible by 5 or 6 or something like that. We would just, you know, kind of increase it and make it go a little bit higher just to make it harder on the human. Obviously, computers can do way better than we can, but this is like a simple Nance that you're looking for in order to teach this to high schoolers and undergrads. And
Okay,
confused
thank you.
graduate. Yeah, sure.
I just really remember it said nonce is a random number.
Yeah, kind of. When you're figuring out a Nance, you're actually iterating through all the possible combinations that you can get. And so when you have a 288-bit number, which is like, you know, if you were to look at all the zeros there, it's like much wider than what my screen is. You're crunching through a ton of possibilities to solve the cryptographic problem with the Nance that you have in Bitcoin. So that's why people are saying, well, look, we got to come up with a different proof of work or some other way to do this, because the computational power required to do this is insane. You know, was it Galib's? Or no, or was it Davi's one with quantum computing? You know, when we have quantum computers, I think this will be trivial. And that's why they're having to come up with new types of cryptography, because elliptic curve cryptography, which is what we use right now, which traditional computers have a real hard time with, quantum computers are not going to have a hard time with. So, you know, you'll have a quantum computer that can essentially do the 51% problem, where it can easily take over 51% of the computational power of the network and start just writing whatever it wants, and no one will be none the wiser. But right now it's really hard, and right now you keep having to up your horsepower to solve this as the Bitcoin blockchain grows, which is actually, if you read some papers, people are very concerned about the environmental impact of Bitcoin, just because of how complicated the math is becoming. That ought to put everyone to sleep. It's almost 10.
All right, other questions?
Thank you.
So like Brother Sid, I was wondering, the block we are connected is a Genesis block, right?
Correct.
So I need to like have a question where I connected to different blocks, not just only the Genesis block and many kinds of other blocks. So I need to identify which block I am like still be what I can say.
Let me show you the handout that this man made. I didn't want to show it because this is his work, but this is him doing this. And he does Nances of 1 to 6, so he's making it a little bit more complicated. So here's the math. This is basically the spreadsheet I was trying to turn into code. And this is what he shows his students. He'll bring in these blocks. He has them pre-cooked, and he'll say, okay, and he'll give them a piece of paper and say, okay, here's a form for you to fill out. Figure out a Nance to put in here. Tell me about it. And when they figure it out, he gives them a water bottle as a reward to say, like, this is kind of what it's like in Bitcoin. You get rewarded with your Bitcoin for figuring out the problem. Mm-hmm. And what he'll show is if some hacker comes in and says, oh, you know what, let's just change some value. Let's get rid of that. Oh, that should have worked. Okay, so we'll change this value right here. Let's change the Nance. Let's just do something like that. Go back to 1. Okay, oh yeah, you know, that's not what it's using. So if I just took and said employee so-and-so, I'll just say K so I know it was me. Oh, this isn't even working. What should have happened is this should invalidate the rest of the block. It's looking at the hashes. When you change data, this is why Bitcoin is so secure. When you change any of the data inside of the Bitcoin block, the computation of the hash is not going to work out. And all the hashes downstream are going to know, you know, I don't match the hash that's behind me, because what you do is you always have, it's kind of like a linked list. You think of a blockchain as a structure. It's a linked list, and the pointers are hashes. You're pointing backwards, and then you put your hash on, and then when the new node comes into the list, it points itself back to you. So if you change something, let's see, can I change you? Yeah, it's going to invalidate everything downstream, because now the hashes aren't lining up. It knows that. Mm-hmm. So I don't know. I'm not sure if I understood your question, Ishtiaq, but like, you're not really looking down the whole chain. You're just looking at the hash that's behind you.
Yeah, I was like wondering that if I connected to more than one block, so I need to figure out that which block I'm in still in state.
So if still in state, are you talking about like Bitcoin forking, or excuse me, blockchain forking, where you have a bunch of people adding blocks on at the same time? Because it is possible for you to, like, if you're on this block, right, if you're trying to sort out this block right here, you know, it's possible that a couple of you could sort it out at the same time.
Okay.
And so you actually end up forking the chain splits off. And I believe the mechanism is for that is people are going to start building on both nodes coming off of that chain. And one of them is going to end up being longer, and that's the fork that you keep.
Oh, so like, well, how do we update that type of forking in blockchain now?
Well, given that I'm working with Nances that are 1 or 3, and actual Bitcoin or blockchain works with, or Bitcoin proof of work works with SHA-256 integers, I don't know. So Mike, how does that work? When the fork happens and they look for the longest chain, how do they figure out where to be tacking onto? Is it just kind of random?
No, it's not random. I have to think how it works, but there's like almost a vote system where they figure out the part of the subchain that has the most number of validations, and they pick that subpart of the chain. I don't think it's not like a real-time vote after that. It's just based on, they roll back to the point where they think that the chain is most valid.
Okay.
Based on total number of validations.
Yeah, the one thing that struck me, this is just an aside as a database administrator, there is a ton of similarity between distributed non-SQL DBs or NoSQL databases and blockchain. It's kind of doing the same sort of thing. You know, you have this widely distributed nodes, and they're all trying to reconcile with each other. Anyways, that's just kind of a random aside. It really is a database mechanism with a very special purpose.
Oh, thank you, brother.
You bet. Thank you.
All right. Anything else? Okay, so let me check something here. 568. Look at the course calendar. All right, so we have emerging technologies coming up next, right?
Yes.
And let's look at that. The calendar looks kind of funky. Give me a
I
sec.
think we don't have any CS assignment.
I think last time you said that it will be on May 7th. Is that correct?
That sounds right to me. I closed the calendar because I clicked the wrong thing. Let me open it again. All right, yeah. Well, okay, yeah. So it's right now.
Yeah.
Yeah, the calendar is correct. I was just reading it wrong. So next week we'll meet for lab, but we only have one embedded systems assignment instead of 2. And then in 2 weeks we'll have basically our final presentations. So what I'll do is for between now and next week, I will put together the final exam, and I'll get it put up online. I'll give you until the end of finals week to finish it, so you'll have plenty of time to do it whenever you want. And then I'll kind of tell you the things to focus on for it, either next week during class or prior to next week on Slack. Sound like a reasonable plan?
So,
do you know when you're going to have the grad classes up to sign up for next semester?
I don't. I'm hoping soon, but it might not be for like another 2 or 3 weeks.
Okay, and is that something like we should be talking to you about soon on like which ones we would be taking, since some of the ones we may have already taken are technically not required anymore?
Yeah, you can.
Okay.
Yeah, that's fine. But we'll make reasonable accommodations for you know what classes will replace whatever classes. So if you're interested in a class, we'll make it work.
Okay.
Dr. Letman, I have a question. So for the exams, there will be time limitation, something like that?
For what?
For the next week exams, like a test.
Oh,
Yeah, so you
the
won't
final.
have the exam won't be in person. I'll make it an online test.
Okay.
I'll probably design the test to take about an hour, but I'll
Okay.
give you, I don't know, 2 or 3 hours to do it. You know, I don't like to make my test time crunches, so you'll have plenty of time to do the test. I'll get it. It'll be up so you can start taking it a week from now if you want. But you'll have until the end of finals week, which is is that the 14th? 15th?
Yeah. 15th, yeah.
So you'll have plenty of time to
Okay.
set aside your couple of hours to work on it. But I'll commit to you that I'll get it up and ready by class next week, so you can kind of decide when you want to do that. Sound
So
good?
there will be short questions, kind of.
That's my plan right now, but give me the week to figure out what I want to ask, and then I'll tell you the type of questions I asked, and then you can prepare for it and take it within that next 2 weeks.
Okay, thank you. Another question is that, and for next another big presentation, emerging technology can be used different 2-3 technology, or we have to have one technology like a kind of presentation.
Well, you could use 2 or 3 different technologies. I just wonder whether or not you would be able to talk about enough stuff. So, I mean, I guess I would say for your annotated bibliography, you'd want to have, you know, you probably would look at 3 or 4 different emerging technologies, and then one of them would be of interest to you.
Okay.
And then, you know, you would probably talk about that. Or maybe you have 2 technologies that are kind of related that you might talk about. So whatever makes sense. I mean, I don't care if you do 2 or 3. I'm just saying that for the presentation, that might be rough.
Yeah.
To fit 3 in there, unless they were, you know, very interrelated. You just want to talk about the differences.
Yeah, we cannot put more than more because we don't have a lot of time. That's the reason.
Yep.
Thank you.
And we don't have any CS assignment, right, for this Sunday?
Correct.
Correct. I think we're done with Bible homework, right?
Yeah.
Yep. Okay. So, any other questions?
Can you rehash for me again? So when are we doing our next round of presentations?
In
or
2
our
weeks.
last presentation? May?
2 weeks from now, May 7th?
7th, okay. Emerging technology. All right, got it. Thank you.
All right. Well, I'll get the everybody's presentation except Maddie's, I think, unless hers got cut off and then re-added. I don't know, but I definitely saw it recording after that. We'll see what happens, but I'll get that uploaded here in a little bit. And I'll see everybody next week.
Yeah.
Good night.
Bye.
Good
night.
Thank you.
Bye.
Bye.
Bye. Good night.